Correct? Beautiful. Good morning, everyone. Today we have the National Science Day. Uh, because of the rains, we had to postpone some of our program, the open day that we have for public, to Sunday. But today we have a few talks. And the first talk is by Dr. Jeevan Pandey, the chair of our astronomy division. And it's on revealing the secrets of the universe from Aries. This will be followed by another talk, which will be on reasons for seasons by myself. And that will be more suited at a more basic level. This is more of an overview of the activities on astronomy and the Aries facilities. So with this, I invite Dr. Jeevan Pandey for today's talk.
Thank you, Viren. But I must say you that this talk is not for you people. This talk is for a very general talk, just to give the overview of what we are doing at Aries and how you are revealing the secrets of the universe. So to show this, you are well aware of this. This is the image that is taken from ILMT, and this is the image taken from 3.6 meter dot. And you are here because of the person who discovered the Raman effect. And in 1928, he got the Nobel Award on that. So starting with so the first of all, I would like to highlight that what is the importance of this place, Nainital. Why you are proud to be at here. So reason for this, you just look into the position of the telescope. The few telescopes, there may not be exactly on the latitude and longitude wise, but at the country wise, fine. There are several telescopes in US, several telescopes in Japan. This is the monarch here somewhere. In Europe as well, South Africa and Australia. And now there is some telescope in China, this is Thailand, and somewhere Indonesia is going to install new 3.8 meter telescope. But there is a gap between this longitude. Just look into that. This is a South African a special astrophysical observatory in Russia. This is a gap between this and Nainital and Henley is somewhere here. So you have a telescope here. So to fill the gap, so for example, any events happen because the astronomers they observe in the night. So what you want to be to follow it up. So we need the telescope in all over the world. So this will follow when here is the morning, here is going to be the day, and here going to be the night. So that is the advantage of this place for observing any celestial events, any event in the universe. So why the telescope again? I have just given you the two things. There are the two circles. I am looking it from here. You just look into the angle is larger. Same two circle at same separation are away from here. You just look into that, the angle is small. Again, if I'll put it away from somewhere here at this corner of the room, then if I look at that, both may be looking at the single objects. So when I put the lens in front of it, these objects, this angle may be, you may find that this angle may be similar to that because of putting of the lens. The use of the telescope is what? The first is that I want to see the universe, I want to see the universe separately, different objects separately. You need to resolve each and every object. This is the use of the telescope. So how well you can separate the nearby objects that you call the angular resolution. So angular resolution, I didn't write the formula here, that is 1.22 lambda upon d. That is the D, the size of the telescope. Bigger the telescope, then you will have better the resolution. This is the diagram that how we evolve with the time. You just see that this is resolution. Resolution means the, I just come to that, this is the angle, again the separation angle. If there is a 1 degree, that means around 60 arc minute or 3,600 arc second. So you want to resolve the stars which are sub-arc second separations, less than sub-arc second separation. So for that, you just see that here, it's still 1609. We don't have any telescope. The first telescope was made by Galileo of the 5 centimeters. Then resolution was increased. Just see, if you have I, you just do the 1.22 lambda d, lambda upon d. Then you just look into the separation around 50 arc seconds, something like that for the visual wavelength. When you increase it, the 5 size from 3 mm, the pupil size is 3 mm, lens size is 3 mm. If you increase the size, then it's a 5 centimeter again. You just see the separate, this is coming around 4 or 5 arc seconds, something like that. Again, in somewhere 1848, yeah, 1840, something like that. I don't remember exactly the date. This is beyond the 1800. Then Herschel's made a 1.122 centimeter of the telescope, then flung back. So you just see that the this resolution becomes approximately 1 arc second, close to 1 arc second. Again, the Palomar came in 1948. There is of the 5 meter. The resolution again increased by a small factor, let's say of sub-arc second. Again, dot lies somewhere, our telescope dot lies somewhere here. See, it doesn't mean that, I'll come to this point. Yeah, I'll come back. Then what you want to see that the sky, I'll come to first this slide, then I'll come back to this one here. See, the star is somewhere here, it passes through the Earth atmosphere. So Earth atmosphere playing a very bad role for us. So what it's doing is that you just see in this image, makes the speckles. That means light rays is coming to in the different layers of the atmosphere, making the several refractions. It may be dancing at all. So by dancing, that makes something like that. I don't have the movie here. And when you add up, you just look into the images for the large exposure time. This is for small exposure time, very few milliseconds or something like that. When it passes through the Earth, so we will have some degradation point, this atmosphere degradation point. So even if you have a better resolution and a larger telescope from the ground, but the sky is such that it plays a role which doesn't want to us to separate, which cannot be separated. There are two close by images, two close by objects in the sky, largely. So that's what we have to go to the space. The sky is now vanishing. So then we can work up to that way. So space, when you went there, then it comes to approximately less than 0.1 arc second, around 0.1 arc second, and JW still is somewhat above this, HST. Nowadays, there is at the point now coming to be the, we call it active optics, adaptive optics. So this AO will help us to mitigate this different layer of the refraction to do that. So you go to the less sub-arc second thing, it's around 0.4, something like that, with the help of AO. Even then with the help of AO, we can do it with the dot, we can achieve to that because up to 0.5 arc second we are going to there with the better sky seeing conditions. So with the advent of this, we have already 1 meter telescope. Then we have, in 2010, we have installed 1.3 meter telescope. Before that era of 1 meter telescope was installed in 1972. It has completed more than 50 years. So before that, we have a smaller telescope as well. I just missed actually to mention here the first paper of the Venu Bapu, then who mentioned that we have acquired here, this is MNRS paper, who mentioned that we have acquired around around 120 acre of the land here for the observatory because of the light pollution in the plain area. Still now we have light pollution here. Now we shifted towards the Devasta to get the better sky nights. So this is the evolution of the telescope installation of the 3.6 meter dot. We just see this one, left to right, and again this. Then finally you have it. And this was a test camera. And with this test camera, you observed the Saturn, very first image of the telescope. As all of you know that we have 3.6 meter diameter. Telescope is always defined by its diameter. We have a 3.6 meter diameter with the primary focal ratio of the f/2, focal ratio that is focal to diameter ratio that is f/2 is f/2, and effective one is primary and secondary additive one is f/9. Back focal length 2.5 meters with the field of view up to 30 arc minute. With the corrector, without corrector, we are using the 10 arc minute. Right. This is the one image that has been taken by the dot imager. You just see this region. This is a one cluster, NGC 1893. So I just say that why the bigger telescope, bigger your eyes, bigger the size, you can separate the images very well. Then आप देख लीजिएगा इधर ही, that you just see that these regions are well separated here in the bigger telescope. So this is the one is star clusters. Why to study these star cluster? As because it is the laboratory for to study the stellar evolution. एक ही एज का स्टार है, बहुत सारे एक्टिविटीज उस पर हो रहा है. Okay. Yeah, telescope alone is not enough. क्या कर लेंगे, आंख से देख लेंगे फिर भूल जाएंगे. So what we need is that to record the event. So to record these events within ARIES, I just highlighted that what are the specific instruments like the polarization measurement. Even the people who can go here, they can go to the measure the polarization, how the polarization happens. It's an important thing. The starlight is polarized. What is the reason behind the polarization? कुछ ना कुछ तो कारण होगा. पोलराइजेशन का कारण हम लोग पढ़ते हैं, that is the reflection, refraction, scattering, several other things. ये सारे reasons होते हैं. तो वो कारण हम लोग पढ़ सकते हैं कि हम क्या कारण है, can go that. ये अभी हमने recently install किया है देवस्थल में, that is Stratford Images, SPIM. Then this is a faint object spectrograph. Now it is giving us very good results. And 10 spec you have already been used. And the new instruments that you are going to install, half the way hai. We call it the high resolution spectrograph for dot. High resolution, एक resolution A है, again high resolution A है. मैंने पिछली वाली slide पे mention किया था. To compare the similar age and the composition. Then how do you know the composition of the star? The star किससे बना है, क्या क्या है. So to know the composition of the star, you use the spectrograph. The spectrograph prism that you know from our childhood. Prism क्या करता है? Disperse करता है light को 7 Ibgyor. So if you want to be more separation of the light, you have used the FOSC. जिसका separation of the lambda upon delta lambda is around 2000 maximum. आइए. और दूसरा ये किस रीजन पर काम करता है? ऑप्टिकल जिसमें हमको देखता है, और ये उस रीजन पर काम करता है जिसमें हमको IR रीजन पे, दैट इज अवे फ्रॉम द ऑप्टिकल रीजन. सिंस 2000 लैम्डा अपॉन 2 लैम्डा 2000 है, देन हाउ वी कैन सेपरेट अराउंड 3 to 4 एंगस्ट्रॉम हम सेपरेशन कर सकते हैं एक वेवलेंथ से दूसरे वेवलेंथ. अब होता क्या है कि आपका डिफरेंट ट्रांजिशन हो रहा है एटम में उधर, क्योंकि आप जानते हैं उधर स्टार्स में बहुत सारी चीजें हो रही हैं. there is a formation of number of the lines. तो उस केस में हमको रिजोल्यूशन बढ़ाना पड़ता है. रिजोल्यूशन तब ये रिजोल्यूशन है लगभग लैम्डा अपॉन डेल्टा लैम्डा 80,000, या डेल्टा लैम्डा अपॉन लैम्डा करेंगे 1/80,000. दैट इज it is approximately separation of the 0.1 less than 0.1 angstrom of the wavelength, ताकि हम उतना सा प्रिसाइज हमको मिल जाए. ठीक है. ये अभी एक डिजाइन है उसका, ये कैसे बन रहा है। ये यहाँ से लाइट आएगी, देन ये प्रिज्म है, क्रॉस डिस्पर्सर प्रिज्म यूज करते हैं। एक बेसिकली हम इसमें यूज कर रहे हैं, यहाँ पर जो पॉइंट लगा है दैट इज कॉल्ड ग्रेटिंग, सेल ग्रेटिंग। वो लाइट को डिस्पर्स करता है, देन फाइनली क्रॉस डिस्पर्सर के थ्रू इट सेपरेट इट आउट करेगा और फाइनली हमको कैमरा में दिखेगा। तो इससे हम क्या पता करेंगे, दो चीजें, एक तो इंपॉर्टेंट चीजें जो आजकल चल रही है, एक तो तारे में क्या कंपोजिशन है, क्या बन रहा है, कोई नया एलिमेंट तो नहीं आया है, और व्हाट इज द ओरिजिन ऑफ द एलिमेंट। जो हमको एलिमेंट्स मिलते हैं उनके ओरिजिन क्या है, वो भी एक हो सकता है, उसका कंपोजिशन क्या है। अगर सर्टेन एक डिफरेंट तारे हैं, हर एक तारे में डिफरेंट डिफरेंट कंपोजिशन क्यों हैं, इवोल्यूशन के साथ कंपोजिशन कैसे चेंज होता है। अगर ये सारी अध्ययन हम करते हैं तो हमको एक सन को भी अध्ययन करने में हम आसानी मिलती है। तो इसी तरह इनका अध्ययन, दूसरा अध्ययन जो आजकल जो एकदम हॉट टॉपिक चल रहा है दैट इज एक्सोप्लैनेट। तो हमने इसको इस तरीके से डिजाइन किया है कि 2 मीटर पर सेकेंड की रेडियो वेलोसिटी तक भी डिटेक्ट कर सके, यानी ये प्रिसीजन आपका लेके आ सके। तो 2 मीटर रेडियो वेलोसिटी प्रिसीजन करने के लिए हमको इन्वायरमेंटल कंडीशन बहुत अच्छी होनी चाहिए। तो वो इन्वायरमेंटल कंडीशन जो हमने यूज की है, अभी हम शायद अभी कुछ दिनों बाद आप देखेंगे उधर के दिन हमने वहां पे एक रूम बना रहे हैं तो फायर के अंडर, तो टेम्परेचर कंट्रोल रूम है जो 20 ± 0.5 ही है ना नंदी, शायद 20 ± 0.5, 20 ± 0.5 डिग्री को अचीव करे, उस तरह का हमें इन्वायरमेंटल रूम बनाना है। एक स्टेज का टेम्परेचर कंट्रोल तो है, दूसरा स्टेज टेम्परेचर कंट्रोल क्या है, ये हमने इधर पर दिया है, ये हमारा वैक्यूम चैम्बर है। दैट अराउंड 10⁻⁻⁶ बार, राइट, मिली बार, सॉरी 10⁻⁻5 मिली बार, 6 मिली बार। इस पर हम एक वैक्यूम क्रिएट कर रहे हैं। साथ ही साथ उसका जो तापमान जो होगा दैट इज 1 मिलियन केल्विन के साथ स्टेबल रहना होगा। अंदर वाला, बाहर वाला दो स्टेज का टेम्परेचर, एक बाहर है एक अंदर है। ये इसलिए क्यों, ताकि जितने भी कंपोनेंट हैं उसके अंदर वो आपके हिले नहीं, कुछ भी ना, कोई फ्लैक्चर ना आए। सो दैट कि जो हमारा 2 मीटर पर सेकेंड की जब वेलोसिटी की बात कर रहे हैं, तो उस वेलोसिटी से हम जो है प्लेनेट डिडक्ट कर सके। नहीं, 2 मीटर पर सेकेंड जो वेलोसिटी क्या कर रहे हैं, मैं अब सिंपल बताता हूँ। ये स्टार है, स्टार के चारों ओर आपका प्लेनेट घूम रहा है, प्लेनेट पास भी आ रहा है, देन दूर, पास आया देन दूर गया, पास आया दूर गया। जब दूर गया तो वेलोसिटी जाती हुई दिखती है। जैसे सिंपल है, बचपन में पढ़ते थे ना, ट्रेन जा रही है ट्रेन आ रही है, आवाज आपकी एक ही बढ़ती है एक ही घटती है। वो सेम चीज यहाँ भी होगी कि दूर जा रहा है तो वेलोसिटी आपकी कम होती जाएगी, यानी रेडर होते जाएगा, नजदीक आएगा तो लोअर होते जाएगा। तो क्योंकि अर्थ का साइज और सन का साइज में बहुत बड़ा अंतर है, तो उस लेवल को डिडक्ट करने के लिए हमको इस तरीके की मेजरमेंट की आवश्यकता होती है, जिसमें ये सब सहयोग हम लोग कर रहे हैं। अ, तो उस मेजरमेंट को करने के लिए हमें इस तरीके का इन्वायरमेंट चाहिए, यानी आपको टेम्परेचर बहुत कम प्रिसाइज होना, टेम्परेचर का वेरिएशन होना ही नहीं चाहिए, क्योंकि हमने उसी टेम्परेचर के लिए बनाया। प्रेशर घटना बढ़ना ही नहीं चाहिए, हमने उसी प्रेशर के लिए बनाया है। अगर थोड़ी सी चीज भी होगी हम कैन नॉट डिडक्ट द प्लेनेट। तो ये वेरिएशन होने के लिए जो हमने 2 मीटर पर सेकेंड का जुपिटर जैसे प्लेनेट या उससे थोड़े छोटे प्लेनेट, सब जुपिटर प्लेनेट को हम डिडक्ट कर सकते हैं। अर्थ वाले प्लेनेट डिडक्ट करने के लिए हमें सब मीटर में जाना पड़ेगा, यानी सेंटीमीटर पर सेकेंड में जाना पड़ेगा। तो वो उस तरह के प्रोसीजन पे जाना पड़ेगा। उस तरह के प्रोसीजन पे जाने के लिए फिर हमें सिर्फ या तो हमें प्लेनेट ही डिडक्ट करते रहे, हमारे और साइंस छूट जाएगी। तो हमने जो इंस्ट्रूमेंट बनाया कि दैट्स मल्टीपर्पज, एक्सोप्लैनेट ही ना करे और उनको भी करे, इसलिए सारे साइंस इसमें इंक्लूड करने के लिए, तो सबको मिटिगेट करने के लिए हमने इस तरीके से 2 मीटर पर सेकेंड रखा, ताकि हम इस लेवल तक के प्लेनेट को भी डिटेक्ट करें, जैसे जुपिटर हमारे चारों ओर है। देन दूसरा टेलीस्कोप हमने फिर लिक्विड मिरर टेलीस्कोप लगाया। दिस इज नॉट अ कॉन्वेंशनल टेलीस्कोप, एकदम खड़ा रहता है, लिक्विड है। मरकरी हम इस पर डालते हैं, मरकरी की मेटल रिफ्लेक्टिविटी बहुत ज्यादा होती है इस लिक्विड की, इसलिए हमने उसको यूज किया है। घुमाने से वो एक मिरर का शेप ले लेता है। तो जब घुमा लिया तो हम इसका मिरर का शेप लेने के बाद, दिस इज द ओरिजिन एंड दिस इज मिरर, और यहाँ पर ही मिरर दिख रहा है आपको। तो कंटिन्यूअसली ये आपको स्काई मूव करता है इस आसमान में, और ये टाइम डिले मोड पे एक एक पिक्सल का देखते जाते, टाइम डिले मोड पे इकट्ठा करता जाता, हम उसका ऑब्जर्वेशन लेते हैं। जो पहली स्लाइड में मैंने इमेज दिखाई थी वो इसकी थी। इससे जो डिस्कवरीज हुई या जो नया चीजें, बहुत सारी चीजें अभी हमको देखने को मिल रही हैं। अभी आप देख लीजिए, ये सारा एस्ट्रॉइड्स हमको डिडक्शन मिला है सारे, और ये स्ट्रीक्स हैं, ये डेब्रीज हैं, मोस्टली स्काई पे डेब्रीज हैं, तो वो भी एक डिडक्शन हमको कंटिन्यूसली हमको मिल रहा है। और मोर इम्पोर्टेंटली जो हमको डिस्कवर्ड हुए हैं यहाँ से, कुछ ट्रांजिएंट्स, कुछ सुपरनोवा डिस्कवर हुए हैं। आई एम सेइंग द डिस्कवर नॉट फॉलो अप। तो मैं हमको पहली बार देखिए, जस्ट सी कैसे डिस्कवर करते हैं कोई भी चीज हम लोग। यहाँ पर हमने एक इमेज देखी है, ये इमेज देखी हमने, यहाँ पर एक नया चीज देखा। अभी नया है नहीं है, फिर हमने पुरानी इमेज देखी तो पुरानी इमेज में कहीं था नहीं। दोनों इमेज को घटा दिया तो हमें एक पॉइंट यहाँ पर मिला, तो यहाँ कुछ नया ऑब्जेक्ट्स था। तो वो नया ऑब्जेक्ट्स क्या है, उसके बाद फर्दर जब हमने स्टडी किया तो पाया कि वो सुपरनोवा है। सुपरनोवा में तारा फूट गया है, अचानक वहां पर बस्ट हो गया है। तो वो सुपरनोवा हमको यहाँ पर मेजर करने को मिला, जिसकी एनर्जी में अभी आगे को बताऊंगा कि कितनी होती है डिफरेंट कंपैरिजन के हिसाब से। ये मेरे ख्याल से होस्ट गैलेक्सी का है, तो ये पुराना एसडीएसएस का इमेज होगा, लगभग 10-15 8-10 साल का पुराना भी हो सकता है। एग्जैक्टली मुझे नहीं पता, बट ये 8-10 साल पुराना भी हो सकता है अप्रोक्सीमेट। ईयर्स भी 8 साल, नॉट मनी तब, या क्वाइट क्वाइट पॉसिबल है पिछले दिन का भी हो सकता है इनका, या कुछ दिन पहले का भी हो सकता है, तो मुझे एग्जैक्टली पता नहीं। हाँ, from the observation, middle one might also be the earlier year observations as well. Same telescope in the earlier time. तो ये तो सारा ये था कि हमें इंस्ट्रूमेंट क्यों जरूरत है इधर, हम क्या करना चाह रहे हैं, हम इंस्ट्रूमेंट की क्या जरूरत है। अब उसके बाद ब्रॉडली हम यहाँ पर करते क्या है। एक तो हम सूरज का अध्ययन करते हैं, उसके रिलेटेड स्पेस वेदर कहते हैं, यानी उससे हमको क्या इफेक्ट पड़ रहा है उसका अध्ययन किया जाता है इधर। दूसरा, सूरज से थोड़ा सा बाहर आए सूरज को अध्ययन करने के लिए, और बाहर आए तो हम आसमान में तारे दिखते हैं। जाइएगा जरूर, देखिएगा आसमान, देखिएगा जरूर, रात को बहुत अच्छा दिखता है, और बहुत सारे तारे देखने को मिलेंगे एल्सो यू दिस, जिसमें हम फॉर्मेशन करते हैं, कैसे तारा पैदा होता है, फिर कैसे वो यंग होते हुए बढ़ता है, जवानी की ओर बढ़ता है, और कैसे मर जाता बूढ़ा होके, ये भी हम पढ़ते हैं इधर। देन उसके चारों ओर कुछ ना कुछ एटमॉस्फेयर होता है, उस एटमॉस्फेयर की स्टडी भी करते हैं। और तारा जो अपनी जिंदगी में एक नियत गति से नहीं चलता, नियत नहीं गति में, एक नियत नहीं, उसकी जो लाइट है हमेशा बदलती रहती है। अब ये बदलाव क्यों हो रहे हैं तारे में, बहुत सारे कारण होते हैं, तो उन कारणों का भी अध्ययन हम लोग इधर पर करते हैं। एक बहुत बड़े कंट्रीब्यूशन है द कम्युनिटी के लिए कि ऐसा क्यों होता है। ये जो फर्दर जो पाइलअप होते जाते हैं, एक फंडामेंटल साइंस में आप कन्वर्ट कर सकते हैं इसको। अगर हम अपनी गैलेक्सी से बाहर आए तो हम उसको एक्स्ट्रा गैलेक्टिक बोलते हैं। गैलेक्सी के बाहर भी हम लोग काम करते हैं, गैलेक्सी के अंदर तो सारे तारे जो हमको दिखते हैं वही है, इवन बहुत इतने तारे हैं कि हमको दिखते भी नहीं है। तो जो गैलेक्सी के बाहर हम बात करते हैं, हम बेसिकली दूसरी गैलेक्सी को अध्ययन करते हैं, ताकि हमारी गैलेक्सी कैसी काम कर सके आगे। तारों का अध्ययन इसलिए किया जा सकता है कि तारे की सन को हम देख सकें, पास्ट में क्या था, पहले क्या था। सबसे नजदीक हमारा यही है, और बिना सन नहीं है तो हम भी नहीं है, तो फिर हमारा कोई एग्जिस्टेंस ही नहीं। इसलिए हमको सन का अध्ययन करना जरूरी ही है। सन को आगे पीछे अध्ययन करना है तो तारों की जरूरत पड़ती है। अब तारे इस गैलेक्सी में, अब हमारी गैलेक्सी को अध्ययन करने की जरूरत है, तो हम कहाँ जाएं। हमारे पास बहुत सारी गैलेक्सी है, तो उन गैलेक्सीज को हम अध्ययन करते हैं जिसमें बहुत सारे इवेंट्स होते हैं, सुपरनोवा, गामा रे बर्स्ट, एक्टिव गैलेक्टिक न्यूक्लियस में थोड़ा सा मैं ग्लिम्स दूंगा आपको। अब ये सब चीजें हमने ऑब्जर्व तो कर लिया है, तो ऑब्जर्व करने के बाद इसको कैसे एक्सप्लेन करेंगे क्या हो रहा है। हमको ऑब्जर्व करते हैं, ऑब्जर्व करने में हमको क्या दिखता है, लाइट तो आ रही है ना, सिर्फ लाइट ही दिखती है, बाकी तो कुछ दिखता है। सन में तो कुछ दिखता है हमको, बहुत कुछ दिखता है। बाकी ऑब्जेक्ट में सिर्फ हमको लाइट, जिसको हम फोटोन कहते हैं, और वो फोटोन भी बहुत कम मिलते हैं। अब उन्हीं फोटोन को देख के हमने बताना है कि है क्या एग्जैक्टली। तो उसके लिए हम क्या करते हैं, एस्ट्रोफिजिकल सिमुलेशंस करते हैं। क्या हो रहा है, एग्जैक्टली क्या हो रहा है, हम प्रिडिक्ट करते हैं कि वहां पर हो क्या रहा है। तो अपना एक फिजिक्स लगा के कि इतना फोटोन आया तो ये हो रहा है, इस तरीके से आ रहा तो ये हो रहा है, तो हम एक सिमुलेशन आके एक रिजल्ट देते हैं कि सामने ऐसा हो रहा है। सुंदर सुंदर फिगर्स आपको देखते हैं, एक थ्योरेटिकल स्टडी से आते हैं। तो ये ब्रॉडली हमारा ये काम है। ब्रेन रोक देना, मुझे जहाँ रोकना हो। मैं अब इधर से थोड़ा सा हिंट देता हूँ। मैं ये तो मैं ब्रॉडली बताया, मैं थोड़ा हल्का सा विस्तार पर जाऊंगा। सन एंड स्पेस वेदर, ये मैं फिगर लिया कहीं इंटरनेट से, मैं जस्ट एक्सप्लेन करने के लिए। इस सन पे बहुत सारी एक्टिविटीज होती हैं। सन पे एक्टिविटी होती है, यानी एक मेजर एक्टिविटी होती है, उसको हम फ्लेयर कहते हैं। यानी अचानक जो होता है सन में फ्लेयर होती है। अब एक होता क्यों है, क्योंकि वहां पे एक मैग्नेटिक फील्ड होता है, चुंबक रहता है बहुत सारा। तो मैग्नेटिक फील्ड का लोकल मैग्नेटिक फील्ड रहते हैं और मैग्नेटिक फील्ड लाइंस होती हैं। साइंस आप पढ़े मैग्नेटिक फील्ड लाइन, वो 10th में एक एक्सपेरिमेंट होता है ना, बार मैग्नेट चारों मैग्नेटिक फील्ड लाइन। कोशिश करिएगा 2 मैग्नेट साथ में रखें तो मैग्नेटिक फील्ड लाइन कैसी आती है। तो यहाँ भी मैग्नेटिक फील्ड लाइन का रिकनेक्शन होता है। वो रिकनेक्शन जब हो जाता है तो मैग्नेटिक एनर्जी, मैग्नेट में अपनी एनर्जी होती है, मैग्नेटिक एनर्जी हीट एनर्जी में, यानी टेम्परेचर बढ़ जाता है, उसमें कन्वर्ट हो जाती है। ये सारे लूप्स दिख रहे हैं आपको। और वो हर एक जब लूप बनता है आगे की ओर, वो लूप करस्पॉन्ड्स टू एक मटेरियल को स्वैप आउट करता है, यानी बाहर निकालता है। उसको कोरोनल मास इजेक्शंस कहते हैं। जब ऐसी स्थिति आती है, कभी कभी क्या होता है, अर्थ का मैग्नेट, ये सारी चीजें हमेशा होती रहती हैं, क्योंकि हम तो कैसा फ्लोट कर रहे हैं एक तरीके से। गैस की 3 स्टेट तो हमने पढ़ी है, सॉलिड, लिक्विड, गैस। सॉरी, मैटर की 3 स्टेट, लिक्विड, गैस और सॉलिड, राइट। जैसे ठोस होता है या तरल होता है या गैस होती है। चौथी स्टेट होती है प्लाज्मा कहते हैं, जिसमें सिर्फ आयन होते हैं। आयन मतलब कि आप एटम है, एटम से निकले हुए हैं सारे। तो मेजर ऑफ द फ्रैक्शन आयन में रहता है। और भी स्टेट होती है, मैं अभी डिस्क्राइब नहीं कर रहा हूँ इधर। पर फोर्थ स्टेट जो प्लाज्मा, हम उसी स्टेट में फ्लोट कर रहे हैं। पूरा यूनिवर्स उसी स्टेट में फ्लोट कर रहा है। तो हमको हमारा, सॉरी, हमारा जो मैग्नेटिक फील्ड लाइंस है, ये मैग्नेटिक फील्ड लाइन क्या करती है, दीज मैग्नेटिक फील्ड लाइन आपको जो यहाँ से मटेरियल आ रहा है उसके करस्पॉन्ड, उसको अपने अलोंग ले जाके या तो बाहर की ओर फेंक देती है, या हमारे अर्थ के पोल की ओर आता है जब बहुत ज्यादा आ जाता है। तो अभी रिसेंटली हुआ था ना अरोरा, वह एक एक्टिविटी हुई तो हायर प्लाज्मा आया, और यहाँ पर आपको ग्रीन लाइट जैसे दिखने लगी थी इधर पोल के पास। तो बेसिकली क्या हुआ, मैग्नेटिक फील्ड के अलावा जो चुंबकीय लाइन थी उसके साथ साथ आपका ये मटेरियल यहाँ से आया और यहाँ पर आयनाइज होते हुए दिखाने लगी आपको। तो कभी कभी ऐसी इवेंट्स हो जाती हैं, तो ये इवेंट्स हमारे अर्थ के कम्युनिकेशन सिस्टम को खत्म कर देती हैं। तो ये कब होंगी हमें नहीं पता है, ये सडनली होती है और खत्म कर जाती है, बहुत बार हो चुका है ऐसा। तो इसको जानने के लिए अब कैसे करें, प्रोडिक्शन कैसे करें। सन का एकदम गूढ़ अध्ययन किया जाए, एकदम माइन्यूटली अध्ययन किया जा रहा है कि हम इनको कैसे प्रिडिक्ट करें। बहुत सारे लोग लगे हैं इसको अध्ययन करने के लिए। हम लोग भी यहाँ से लगे हैं इसको अध्ययन करने के लिए, कृष्णा बैठा हुआ है, ये सब लोग उसका अध्ययन करते हैं। ये मैं कुछ फिगर्स में दिखा रहा हूँ, ये रियल फिगर्स हैं। ये कैसे कैसे इसमें हो रही है, आप देखिएगा। हर एक फिगर को देखिए, हर एक ओरिजिनल है, स्पेस टेलीस्कोप से ली गई है सबके सब। आप देखिए कैसे हो रहा है सर, सारी इस तरीके से एक्टिविटी सन पे होती रहती है। इसको हम एक कोरोनल रेन बोलते हैं इधर ही है। और सारी फ्लेयर्स, ऑल दीज थिंग्स, ये मटेरियल कैसे इजेक्ट हो रहा है इधर। यही मटेरियल मैं कह रहा हूँ जो आपसे इजेक्ट हो रहा है हमारी तरफ आ गया, तो खुशकिस्मत है कि हमारा मैग्नेटिक फील्ड हमको बचा देता है। अगर ये नहीं होता तो हम जाते हैं। तो ये चीजें ये है। अब लेकिन हम, अब पॉइंट ये आते, ये तो हमारे क्या, हमारे पास सन का डेटा कितने साल का है, 400 साल, थोड़ा सा ज्यादा 400 साल से। और अच्छा डाटा पिछले 50 सालों से ही है। अच्छा डाटा मतलब प्रिसाइज थिंग्स की हम और मेजरमेंट करें, तो 400 साल के डेटा से क्या हम 4.5 यानी 4.5 अरब को प्रिडिक्ट कर सकते हैं। थोड़ा सा टफ है। तो हम क्या करने, हमारे पास ऑप्शन क्या है आप, वी हैव स्लाइटली, ये अच्छे मैं बता चुका हूँ। तो व्हाट आर द ऑप्शन। तो हम स्टार्स को देखने चले गए आसमान में, चलो स्टार्स, एक्सप्लोर द स्टार्स, स्टार्स को एक्सप्लोर करें। अगर हम आसमान को देखते हैं एक सीजन पे, अभी जाड़ों के सीजन पे आपको गैलेक्सी का स्ट्रिप दिखता है, इसी तरीके से दिखता है, बट एक क्लस्टर है, एक फॉल्स कलर दिए गए, फॉल्स कलर करस्पॉन्डिंग टू देयर ओरिजिनल कलर एक्चुअली। इसमें क्या है, डिफरेंट कलर दिख रहा है ना एक तारे का, हर एक तारे का अलग, कोई तारा नीला दिखता है, कोई लाल दिखता है, कोई पीला दिखता है। एक एक दूसरे इसका रंग अलग अलग क्यों, हर एक का रंग अलग अलग है, मतलब उसका तापमान अलग अलग है, जो उसका बाहरी तापमान है, इफेक्टिव टेम्परेचर अलग अलग है। लाल तारा मतलब थोड़ा ठंडा है, येलो थोड़ा गर्म है, सन जैसा है, सूरज जैसा है। और जो ब्लू है बहुत गर्म है वो, उसका टेम्परेचर लगभग 40,000 कैलिन या 10,000 कैलिन ज्यादा है, या 10,000 डिग्री सेंटीग्रेड से ज्यादा है। अगर मैं इनका डिस्ट्रीब्यूशन देखूं तो ब्लू स्टार यानी जो नीले तारे लगभग 4% है। नीले तारे बहुत मैसिव है, सन से लगभग 10 से लेके 100 गुना तक भारी है, उतने ही बड़े भी हैं। येलो स्टार यानी सन टाइप के स्टार 7 है, 7% है टोटल स्टार की गैलेक्सी में। व्हाइट डॉफ हम उसको कहते हैं जो जब मर गया है तारा तो बना क्या है, व्हाइट डॉफ, उसको 9% है। जाइंट एक स्टेज ऐसी आएगी, सन इवॉल्व होगा, बहुत बड़ा बनेगा, वो 1% है। रेड डॉफ यानी ऐसे तारे हैं जो लाल दिखते हैं, एकदम लाल दिखते हैं आसमान में, लेकिन हमको बहुत कम दिखते हैं आसमान में, कारण कि वो बहुत छोटे होते हैं, इसलिए उनकी चमक भी बहुत कम होती है। तो सबसे ज्यादा तारे वो है। अब ये तारे सबसे ज्यादा क्यों, कारण क्यों हो सकता है ये तारे ऐसे ज्यादा पैदा कैसे हो गए, क्योंकि इनकी उम्र बहुत ज्यादा है। जो ब्लू तारे हैं इनकी उम्र बहुत कम है, मोटे हैं जल्दी फट जाते हैं, तो मोटा होना अच्छी बात नहीं। तो पतला रहे तो बेटर रहे, तो पतला होंगे तो आपकी पॉपुलेशन भी बढ़ रही है, और मोटे होंगे तो पॉपुलेशन आपकी घट रही है। दैट इज ऑल्सो इफेक्टिव हियर, है ना। हाँ ये मैंने लिखा है इधर, सॉरी। क्यों इतना ज्यादा है, बिकॉज दे आर हेल्दी, खुश किस्मत है एकदम, ना कोई बीपी ना कोई हार्ट अटैक, कुछ नहीं होने वाला इनको, देन दे आर लॉन्ग लाइफ एंड पूरा स्काई में डिस्ट्रीब्यूटेड है। ये हेल्दी तो है, लेकिन इनकी परेशानियां और भी हैं। एक तो इनमें काले धब्बे हैं, जैसे सन पर होता है, इनमें काले धब्बे इतने ज्यादा है, कभी कभी इनका 35% उनका सरफेस एरिया पूरा है जो सन का है, उसमें सन में 2% है, इनमें 35% तक भी ढक जाता है, तो दाग तो रहेगा इन पे, इसलिए वो थोड़ा सा ठंडा और ठंडा कर देते हैं। अब मैंने कहा ना सन को हमको जानना है, तो सन को जानने के लिए हम करें क्या आप, तो आप इस फिगर को देखिए। ये 13 दिन कंटिन्यूस ऑब्जर्वेशन लिया गया, एक सैटेलाइट, 5 मिनट है, चलो कोई बात नहीं, कंटिन्यूस सैटेलाइट से ऑब्जर्वेशन लिया गया। आप देखिएगा तो आप इसमें देखेंगे लाइट, देखिए आपकी एकदम चमक बढ़ जाती है। तो जब ये चमक बढ़ती है तो इसकी एनर्जी लगभग आपकी 10 की घात 25 वाट, 10 के आगे 25 शून्य लगाएंगे उतनी वॉट हो जाएगी। और हमारी हीटर का कितना हो, जो हमारे कमरों में रखा है आजकल, 3 किलोवाट मैक्सिमम देता है। अगर हीटर हम कंटिन्यूअसली अपने पास रखते हैं तो हमें गर्मी लग जाती है, ऑफ तो करना ही पड़ता है। 10 के आगे 25 लगाएंगे तो कितनी एनर्जी हमको मिल रही है। सन के केस में क्या हो रहा है, 10 की घात 20 के आसपास मिलता है, इतना ही है ना एनर्जी, बस सही हो डेटा में, इट्स ऑलमोस्ट 10 to the 20 राइट, द X28 फ्लेयर समथिंग लाइक दैट। ओके, तो ये इतनी एनर्जी आती है। तो इसमें हम क्या करते हैं, हम ऐसे ही सिमिलर सारे तारों को जो सूरज के बराबर, सूरज से पहले भी सूरज के बाद में भी, वो क्योंकि हमारे पास लेबोरेटरी, मैंने कहा ना आसमान बहुत अच्छी लेबोरेटरी हर चीज का अध्ययन करने के लिए। तो सन का अध्ययन करने के लिए हमारे पास इतने सारे तारे हैं, जो सूरज के पहले वाले तारे हैं यानी अभी पैदा हो रहे हैं, उनका भी अध्ययन कर लिया। सूरज के बाद वाले तारे जो मरने वाले हैं अभी, कुछ मोटे होके फैल चुके हैं और कुछ डेड हो चुके हैं, उन सबका एक अध्ययन करके हम एक इवोल्यूशनरी ट्रैक बना रहे हैं कि सन कहाँ की ओर जाएगा। अब इनका हम क्या कि प्रिसाइज एक अध्ययन चाहिए, तो हम एक सन का प्रोडिक्शन कर सकते हैं कि नहीं ऐसे हो सकता है। जो फ्लेयर आ रही, जो इतनी फ्लेयर आ रही, क्या सन में अगर ऐसी फ्लेयर आ जाएगी इतनी एनर्जी की, अभी तो 10 की घात 20 में हमारे कम्युनिकेशन सिस्टम खत्म हो जा रहे हैं। अगर ये एनर्जी अगर सन पे अगर प्रिडिक्शन हुई तो मतलब ध्वस्त हो जाएगा पूरा। पूरा कम्युनिकेशन सिस्टम गोस, वी डोंट नो व्हाट विल हैपन, वी नीड टू प्रेडिक्ट इट। अगर एक जापानीज ग्रुप का एक पेपर था कि ये प्रेडिक्शन किया गया है सन पे, सोलर फ्लेयर आफ्टर एवरी 100 or 200 ईयर, समथिंग लाइक दैट। दूसरा, ये जो तारे होते हैं इन्हीं में, हमारा सन भी ये पल्सेट करता जैसे दिख रहा है, ऐसे पल्सेट करता है, छोटा भी होता है बड़ा भी होता है। अब ऐसा क्यों होता है? छोटा होना मतलब कि ग्रेविटी पुल कर रही है, बड़ा होना मतलब अंदर से प्रेशर आ रहा है, हीटिंग प्रेशर आ रहा है, उसको बाहर कर रहा है, तो कंटिन्यूस होता है। ये वाला अध्ययन ऐसा होता है, ये वाला मेरे ख्याल से फेमस है, सभी लोग ब्रिजलाल जाके हम लोग ईसीजी लेते हैं ना, इट्स लाइक ईसीजी, पल्सेशन हो रहा है, पल्स करता है ऐसे। ये है ईसीजी हमारा इस तारे का, ये भी पल्स करता है। ये एक सर्वे किया गया नैनीताल और कैप में 1999 में हम लोगों ने, उसमें पहला तारा ऐसे डिस्कवर हुआ जिसका पल्सेटिंग मिनट, जो पल्सेशन पीरियड है, नहीं जो पल्स कर रहा है, 7.7 मिनट, बहुत ही कम था उस सर्वे में। ये 300 या 400 तारे हम लोगों ने सर्वे में किए इधर 1.1 मीटर टेलीस्कोप से। इसमें फर्स्ट डिस्कवर्ड स्टार ये है कि इसमें पल्सेशन है, और 7.7 मिनट का इसका पल्सेशन पीरियड मिला था। तो इस तरीके से पल्सेशन को डिफरेंट पीरियड्स पल्सेशन के मिलते हैं। तो ऐसा ही सन पे भी होता है, जैसे अराउंड 5 मिनट पल्सेशन पीरियड। तो हम कैसे देखें इसको? ये तो तारों की बात ही, अगर तारों से बात जा जाते हैं, दैट्स नियर्ड मिल्की वे। तो मिल्की वे, क्योंकि हम रहते हैं कि आगे भी पीछे भी, हम पीछे तो देख नहीं सकते, एक स्ट्रक्चर हमने बनाया कि मिल्की वे किस तरीके से दिखती है। ये इसका सेंटर है, हम यहाँ पर है, एक पॉइंट यहाँ पर है, हम लोग सन पॉइंट है, हम नहीं है, सन पॉइंट है। उस पॉइंट की ओर हम घूम रहे हैं, अर्थ घूम रही है, और अर्थ में हम रहते हैं, तो हमारी एग्जिस्टेंस कुछ भी नहीं है इवन देन विद इन अ गैलेक्सी। हम यहाँ से इधर की ओर भी देख सकते हैं, इधर की ओर भी देख सकते हैं। तो अर्थ में गैलेक्टिक सेंटर है, बाहर की ओर है एंटी सेंटर डायरेक्शन से। ये दो आर्म परसेस आर्म है और एक सेंटर आर्म है, ये आपको दिखती है। तो हम अब इसका अध्ययन करने के लिए गैलेक्सी है, सन गैलेक्सी में है, यहाँ इधर है, वो किस इन्वायरमेंट में पैदा हुआ, कैसे पैदा हुआ, या बाकी इसका किस इन्वायरमेंट में पैदा हुआ, उसको अध्ययन करने के लिए बाकी गैलेक्सी का भी अध्ययन करना पड़ेगा हमको। तो जिज्ञासा तो यही खत्म नहीं होती है, उसकी जिज्ञासा और बढ़ाते हम और आगे बढ़ते हैं, तो फिर हम गैलेक्सी की ओर गए, बाहर की ओर गए, अपनी गैलेक्सी से बाहर भी देखना शुरू कर दिया हम लोगों ने। अब बाहर देखने के लिए फिर हमको क्या चाहिए? बड़ी टेलीस्कोप चाहिए, दूर जाना है। जितनी बड़ी टेलीस्कोप होगी उतना दूर जाएंगे, उतना फेंट हम ऑब्जर्व कर पाएंगे। दूर जाना मतलब हम फेंट देख रहे हैं। ये देखिए दूसरा है, आप देखिए इस तरह की गैलेक्सी, यहाँ हजारों गैलेक्सी पड़ी। जैसे भाई तारों का एक क्लस्टर था, मैंने पहले दिखाया था आपको इधर, इस तरीके से तारों का एक क्लस्टर था, उसी तरीके से अब यहाँ पर गैलेक्सी का भी क्लस्टर, इतनी सारी गैलेक्सी है। एक गैलेक्सी में लगभग 100 बिलियन, यानी 100 अरब तारे होते हैं, और इतने ही लगभग आपकी गैलेक्सी प्रेडिक्ट की गई, 100 अरब गैलेक्सी। आप समझ सकते हैं, अभी मैंने आपको दिखाया है, ये पॉइंट है यहाँ, सन एक पॉइंट है, हम उसके चारों ओर घूम रहे हैं, और इतनी ही कितनी सारी गैलेक्सी यहाँ जो है, 100 अरब गैलेक्सी है। तो हमारी एग्जिस्टेंस कुछ भी नहीं है। यानी इस तरीके से है जैसे हमारे लिए एक सेल है किसी पत्ते की, जो हमको दिखती तक नहीं। तो आप एक एग्जिस्टेंस दिखाइए तो कुछ होता है। तो हमें इस तरह का अध्ययन करने के लिए देखिए सारी गैलेक्सीज हैं, फिर हम गैलेक्सी का भी अध्ययन करते हैं। गैलेक्सी का अध्ययन बहुत जरूरी है, इसमें स्टार कैसे पैदा हो रहे हैं, क्या हो रहे हैं, तो हमारी गैलेक्सी में हम अपनी तरह की गैलेक्सी को पढ़ते हैं। इन चीजों का अध्ययन भी हम क्लस्टर ऑफ गैलेक्सीज का भी हम इधर से करते हैं। इधर मैं एक एग्जांपल देता हूँ जो दूसरी गैलेक्सी में हो रहा है। मैंने कहा था ना सुपरनोवा जो कैसे 3.6 ILMT से डिस्कवर हुआ था, तो बेसिकली ये इस तरीके से होता है। तारा है, ये किसी भी तरीके से एक्सप्लोर कर सकता है, क्योंकि इसका रेडिएशन प्रेशर आगे से अंदर जो तारा में जो एनर्जी पैदा हो रही है, वो न्यूक्लियर बम फट रहे हैं, यानी हाइड्रोजन बम फट रहे हैं। तो हाइड्रोजन बम कभी फट के हीलियम बम बन जाता है। जब हीलियम बम इतना तेज फट जाता है तो एक्सप्लोड करना शुरू कर देता है, क्योंकि ग्रेविटी उसको नहीं पकड़ पाती, नहीं रोक पा रही है। क्या करेगा? अगर हम अंदर से ताकत लगाने, बाहर से अगर अंदर वाली ताकत ज्यादा है तो बाहर की ओर फेंकेगा ना, ये बाहर की ओर फेंक रहा है पूरा। लेकिन ये तो मैंने बोला था ना, हम सिमुलेशन करके बताते हैं ऐसा हो रहा होगा ऐसा। लेकिन ऐसे जानते कैसे हैं? उसके लिए हमें उन तारों को, उन ऑब्जेक्ट्स को कंटिन्यूअस ऑब्जर्व करना पड़ता है। देखिए इधर ये सिर्फ तारे की लाइट है। तारे की लाइट हम कंटिन्यूअसली ऑब्जर्व करते हैं, ये कितने दिन तक, 200 दिन तक ऑब्जर्व किया, देखिए आप। तो शून्य दिन यहाँ भी पी गया 200 से पहले, इन 220 दिन करीब ऑब्जर्व किया गया है। अब 220 दिन देखिए अचानक बढ़ जाते हैं, सडनली बढ़ता है, लेकिन फिर धीरे 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 होता है। ये कैसे फिर रहा है, ये कैसे जा रहा है, ये सब डिपेंड करता है। उसी तरीके से हम उसको उल्टा सिमुलेट करते हैं कि क्यों हो रहा है ऐसा। हर एक ये शेप हमको बताएगा कि कैसा है। और हमको क्या मिल रहा है वहां से, सिर्फ प्रकाश, और प्रकाश के भी कुछ कण, और कुछ नहीं। उसी कणों को हमने बताना है कि क्या हो रहा है। तो एक ही सुपरनोवा है, और इसकी एनर्जी आप देख लीजिए, 10⁻36 वॉट आती है। ये 10 के आगे 36 शून्य लगाएंगे, उतनी ही एनर्जी मिलेगी। और कितने हीटर होंगे बताइए आप, ये 10 के आगे हम 33 हीटर लगाने, तब जाके हमको मिलेगी उतनी एनर्जी, राइट। ये दूसरा इवेंट है जो गामा रे बर्स्ट, जो हमने 99 में स्टार्ट किया था। 1997 में पहला ऑब्जर्वेशन यहाँ से हुआ था, इंडिया से पहला ऑब्जर्वेशन हुआ था। इवन वर्ल्ड का सेकंड या थर्ड ऑब्जर्वेशन था गामा रे बर्स्ट का। तो गामा रे बर्स्ट होता कैसे है, वो भी इसी तरीके से होता है, तो सुपरनोवा ही हो या गामा रे बर्स्ट दूसरे तरीके से होता है कि मर्जिंग ऑफ द टू स्टार्स होता है। दो स्टार मर्ज कर जाते हैं, जब मर्ज को करते हैं तब बहुत सारी एनर्जी जनरेट होती है। तो एनर्जी जनरेट होने पे फिर अगेन कैसे हम पढ़े, हमको तो ऐसा दिख नहीं रहा है उधर, अगेन प्रकाश के थोड़े कण आते हैं, उनको हमने फॉलो अप किया कंटिन्यूअसली। देखते हैं ऐसे ऐसे बिहेवियर कर रहा है, गिर भी रहा है, लेकिन अपने आप में कुछ बिहेवियर भी कर रहा है। तो ये या मैं कुछ गड़बड़ लिख दिया इसको, नॉट 1000 टाइम्स, इट्स अराउंड 10⁻33, 10⁻52 आवर्स लगभग। ये बहुत ज्यादा है, नॉट 1000 टाइम्स। इस इस है इस लगभग आप 10 के आगे 15-20 शून्य लगा देंगे तो उतनी ज्यादा एनर्जी आपकी रिलीज हो रही है सन से। और हीटर तो आप ना पूछिए आप कितने होंगे। तो एक एक इवेंट ये इवेंट 99 पहली बार हम लोगों ने यहाँ से ऑब्जर्व की थी। दूसरा इंटरेस्टिंग ऑब्जेक्ट्स और है, ब्रेन मेरे को मना कर रहा है, अब मत बोलो। हाँ, उसके बाद और है, पता नहीं आने वाले हैं। कोई बात नहीं, ठीक है। आप सुनना चाहेंगे तो मैं कभी और बोल दूंगा, कोई इशू नहीं। तो आप भाई इंटरेस्ट शो कर दीजिए, मैं बोलने को तैयार हूँ। तो ये दूसरा एक एक्टिव गैलेक्टिक न्यूक्लियाई हम लोग करते हैं, इसका भी हम कंटिन्यूस ऑब्जर्वेशन करते हैं इधर से। तो एजीएंस, अच्छा ठीक, ठीक ठीक है। हाँ, तो एजीएंस एक्टिव गैलेक्टिक न्यूक्लियाई वो होती है जिनके गैलेक्सी के सेंटर में ब्लैक होल होता है। अब समझते हैं ब्लैक होल है क्या भला। जब स्टार, मैंने पैदा होने की कहानी तो नहीं बताई, स्टार पैदा होता है, स्टार पैदा होता है, अगर आप आसमान, क्लियर आसमान होगा कल परसों में, जब भी आप आसमान की ओर देखेंगे, हमको एक बेल्ट दिखती है आजकल, दिखती है, दैट इज परसे शाम दिखता है आजकल, परसे शाम आपको एक दिखता है। आप देखेंगे तो हमारे जो गैलेक्सी, हमारी बादल जैसे ना, वैसे बादल दिखता है पूरा एक लाइन से इधर से ऐसे करके। वो बादल बेसिकली है बादल, बट किसका है, हाइड्रोजन मॉलिक्यूल्स का। तो हाइड्रोजन मॉलिक्यूल्स का बादल में जो होते हैं तारे पैदा होते हैं। वो तारे किसी न किसी कारण से पैदा होते हैं, कारण क्या होगा, कुछ ना कुछ तो एक्सटर्नल रीजन चाहिए, किसी ने उसको धक्का देना चाहिए तो थोड़ा हिल जाएगा। जब हिलेगा तो उसमें क्या होता है, कोलैप्स होता है, यानी वो गिरने लगता है अपनी ग्रेविटी की वजह से। क्योंकि गुरुत्वाकर्षण है, गुरुत्वाकर्षण हमेशा एक पॉइंट पर लाने की कोशिश करेगा उसको। तो अपनी ग्रेविटी की वजह से जब हिल के एक पॉइंट पर आता है, तो धीरे धीरे उसका जो ग्रेविटेशनल एनर्जी जो होती है, एक नियम के अनुसार आधी एनर्जी जो होती है हीट में कन्वर्ट हो जाती है। जब टेम्परेचर बढ़ रहा है तो मॉलिक्यूल है ना, टूटेगा तो सही, किसी चीज को उबाल रहे थोड़ा सा टूटेगा तो सही है, तो मॉलिक्यूल टूट के एटम बनेगा। इसी तरीके से फॉर्मेशन का प्रोसेस होते जा रहा है। एटम टूट के, एटम से फिर इलेक्ट्रॉन, इतनी एनर्जी जब होगी एटम से हाइड्रोजन से इलेक्ट्रॉन निकल जाए तो न्यूक्लियस बचेगा। फिर इतनी एनर्जी आ जाए, लगभग 10 लाख केल्विन की एनर्जी, 10 लाख सेंटीग्रेड टेम्परेचर हो जाता है, तो दो हाइड्रोजन न्यूक्लियस जो होते हैं एक हो जाते हैं, न्यूक्लियर एटम बम, सर क्या बोलना है उसको, परमाणु बम नहीं हुए ना ये, न्यूक्लियर बम हुए, नाभिकीय बम कहते हैं, हाइड्रोजन बम कहते हैं जिसको। तो हाइड्रोजन बम का फूटना होता है, हाइड्रोजन बम का फूटना मतलब उनका संलयन होना, यानी एक होना है। तो जो हाइड्रोजन बम फूटते हैं यानी एक हो जाते हैं, तो हाइड्रोजन बम एक होने के बाद उसका हीलियम बन जाता है। तो हाइड्रोजन से हीलियम बनने में क्या होता है, मास डिफेक्ट आता है, यानी जो हीलियम का ओरिजिनल मास है और हाइड्रोजन को बन के जो मास है उनमें अंतर आता है। जो मास डिफेक्ट जो होता है वो डेल्टा एम जो है वो जाएगा कहाँ? तो आइंस्टीन थे, हमने उन्होंने बताया कि ये एनर्जी में कन्वर्ट होता है, तो डेल्टा एम सी स्क्वायर, राइट। वो एनर्जी में कन्वर्ट होता है, वो एनर्जी जो जनरेट होती है सन के सेंटर पे भी हो रही है और तारों के भी सेंटर में जब फॉर्मेशन होता है वही एनर्जी हमको मिल रही है, उसी की हम लोग खा रहे हैं। यानी हाइड्रोजन बम यहाँ फूट जाए तो हमें डर लगता है, लेकिन वहां फूट जाए तो खुशी होती है। अगर नहीं फूटेगा तो नहीं मिलेगा ताकत, हम लोग नहीं रहेंगे। तो वो एनर्जी जब हाइड्रोजन बम फूट रहा है तो वो एक तारा यंग हो जाता है। अब एक सर्टेन स्टेज से कितना हाइड्रोजन होगा उसके अंदर, खत्म भी तो होगा फ्यूल, फ्यूल होके हीलियम में कन्वर्ट हो जाएगा। फिर हीलियम फूटना शुरू होगा तो तब क्या होता है, एक ब्लास्ट होता है, यानी फैलना शुरू करता है तार। सन के केस में भी ऐसे ही होगा, वो फैलेगा और इतना फैल जाएगा कि वो हमको भी ले लेगा अपने उसमें। तो उस दिन समझ लीजिए पर ये प्रलय आ गया। लेकिन प्रलय आने का समय है अभी। अभी हम 5.5 साढ़े 4 अरब साल हुए हमको, इतना ही समय और है। तो हमारे तो उम्र 10 20 साल 25 साल कुछ भी नहीं है, तो चिंता करने की तो बात नहीं है ज्यादा, राइट। तो इसी तरीके से जब मैं तो इधर पाने वाला था ब्लैक होल कैसे बनता है, तो धीरे धीरे क्या होगा, वो बाहर वाला मटेरियल खत्म हो जाएगा, फिर अंदर वाला मटेरियल जो बचता है, क्योंकि फैल जाता है, फैलने से बाहर वाला मटेरियल बाहर चले जाएगा, अंदर वाला सिकुड़ने लगता है। तो सिकुड़ने की वजह से उसकी कॉम्पैक्टनेस हाँ बढ़ जाती है। तो कॉम्पैक्टनेस बढ़ने से क्या होगा, यानी ज्यादा ज्यादा स्ट्रांग हो जाता है। यानी आपका जो टोटल मास जो होता है इसका 1 किलोमीटर या 2 किलोमीटर 10 किलोमीटर के अंदर में समा जाता है, तो बहुत ही कॉम्पैक्ट हो जाता है, तो लाइट भी उसके थ्रू पास नहीं होती, तो उसको हम ब्लैक होल कहते हैं। तो ये अज्यूम किया जाता है इस गैलेक्सी के सेंटर में ब्लैक होल है, तो वो बहुत ही एक्टिव है, इसलिए उसको एक्टिव गैलेक्टिक न्यूक्लियर बोलते हैं। हम इसका भी अध्ययन करते हैं, ये कैसे बिहेव कर रहा है, कैसे इवॉल्व कर रहा है, ये सब चीजें हमारे यहाँ पर है। हालांकि मैं कोशिश की आधी चीजें मैं बता पाया हूँ, जो हम आधा करते हैं ये ब्रॉड वे में कि कैसा होता है। तो अगर किसी को जरूरत हो कभी आप नॉर्मल ऑडियंस को, तो आई कैन समराइज मच मोर बेटर। हाँ, थैंक यू। प्रश्न पूछना तो पूछ सकते हैं। बारिश का मौसम अच्छा है, तैयार है। वाह। और आप अभी दूसरा टॉप जो स्कूल के बच्चों के लिए है वो बस शुरू होने वाला है, स्टूडेंट आ चुके हैं। So I would request for any discussion and for tea, please proceed outside. थैंक यू। ठंड पानी में आएगा क्या? ठीक है, पानी गर्मी में है। आग में ट्रेन गया मतलब।
Silence, please. Come from the other gate. The people who are coming can change the gate from that side. Please go to this side. Hurry up.
All right, settle down, everyone. Everybody, please settle down. Shall we begin? Okay. So all of you are coming from Delhi, and I'm told you are from class 5 and class 6. Is that correct? Okay. All right. So now, today is the National Science Day. Does anyone know why? Why? What is the reason? Any guesses? Yes? Today science was invented. No. Science is just, thinking about something and applying some logic to that. So that was done by, forget about humans. I mean, if you see animals, even they do that. So yeah, science in that sense probably predates humans. Obviously, the people, our ancestors who used to roam around jungle, they might have been curious about things. But okay, formally it probably started after, we started having civilizations and things like that. Anyway, so 28th February is, yes. Don't worry, if it's wrong, it's fine. No, no, no. Anybody else? All right. So have you, yes? No. Yes. Maybe we took some huge leap forward in some sense. Yes.
Something new was invented.
Oh, so now we are almost getting towards the right answer. So have you heard of, yes, there. Yes. Okay. Even better answer. Yes. Right. So all of you are getting there. So what happened was, so okay. So you are approaching the right answer. I will just tell you because we also have to cover a lot of things. So have you heard of someone called C.V. Raman, Chandrasekhar Venkatraman? Yes. Who was he? Any idea? He was a scientist. Yes. Physicist. Yes. And
He had made some discoveries in the topic of matter.
okay. Yes. You're right. Yes. Right. So he discovered something, and that concept, what he discovered, basically, so he did not invent that. Huh? Invention is when you make something, you develop some sort of a technology and all. That's invention. But discovery is something which is already there in nature, and you find out the reason behind that, or you find something that already is there in the nature. That's called discovery. So he discovered something, and basically how the light behaves and gets, although reflected is not the correct term. The correct term is scattering, but you are too young to probably understand that. So for the time being, you can just remember this, that he discovered something called as Raman effect. Yes. No, no, that was not done by him. So he discovered the way light gets scattered by materials, and some, because of that scattering, there is some change in the light. So that's what he's discovered, and that was in February 1928 when the final discovery was announced. It was 28th February 1928. And as a result, he got the Nobel Prize in Physics in 1930. Okay, and that's why this day is declared as the National Science Day. He was the first Asian person to win a Nobel Prize in physics, and later on he was also honored with Bharat Ratna. And this day, for like past many decades now, India celebrates as National Science Day. Okay, so basically, if you visit any research institute on this day, or maybe around this day, they will have different kind of activities for public, for students and things like that. Now we also were going to have these activities, and we were going to show you telescopes. We were going to show you the sun with the telescope and things like that. But you can see the weather outside. Unfortunately, the weather played a spoil sport, and because of the clouds, all those activities won't be possible. So, welcome to Aries. My name is Dr. Virendra Yadav. And before we discuss something about science so that you learn something, we have a short video on Aries, what we do at Aries, with our telescopes and all. Because as I said, that we'll not be able to visit the telescope, but in the video, we'll be able to see the telescope. Now, some of these things probably may be suitable for a little higher classes. So don't worry too much about that. Just see the video. With the video, you'll get some idea about our activities, and then we'll proceed with the second part. Okay, Javed, please, could you start?
The beauty of night sky and the celestial events that takes place at that time are both stunning and compelling. Since the beginning of human civilization, we have looked to the sky to navigate vast oceans, to decide when to plant our crops, and to answer questions of where we came from and how we got here. This curiosity of ours has introduced astronomy to mankind.
This is actually a branch of physics where it allows us to verify various branches of physics experimentals, which we cannot do it in terrestrial environment. But also, of course, the night sky always, attracts us, and this curiosity about, how we are born, how the universe was born. So that's a natural questions we all have.
Being a leading research institute of the country, Aries specializes in observational astronomy, astrophysics, and atmospheric sciences. The legacy of the institute goes back to more than 6 decades. First, as a straight observatory established in Varanasi in 1954 in Uttar Pradesh, at the initiative of Dr. Sampurnanand, Education Minister and later the Chief Minister of Uttar Pradesh at that time, and Professor A.N. Singh, a professor of mathematics at Lucknow University. In 1955, it was shifted to Nainital to get clear sky in the hills. It was the dream of then director of the observatory, Professor Venu Bapu, a highly respected astronomer in optical astronomy, to establish a 4-meter class optical telescope in India. The state observatory started with modest facilities until a 1-meter optical telescope was established in 1972 at Manorapi. It then started flourishing. Aries come under the aegis and funding of the Department of Science and Technology, Government of India in 2004. The key instrument of nearly all modern observational astronomy is the telescope. These telescopes serves the dual purpose of gathering light and magnifying the image, so that small and very faint objects of galaxy can be easily observed.
The light actually comes from far, far away. And so the light becomes very faint when you compare it with any terrestrial light which you see around, like your lamps or headlight. This light is actually having only few photons per second. And that's why it's called the faint object spectrograph camera. Now, the light which is coming from these celestial objects from very, large distances, they need to be analyzed for each and every color.
Most of these observational astronomy is performed through telescopes of different apertures, from the ground-based observatories located at high altitude so as to minimize the absorption and distortion caused by Earth's atmosphere and maintain the accuracy of those observations. Aries enjoy being based at one such favorable location. The Atmospheric Science Division at Aries carries out research on air pollution and climate change. Here, the focus of research is mainly in the lower part of the atmosphere. This division specializes in observation of trace gases, including ozone and greenhouse gases, aerosols, and meteorology, etc.
This ST radar, which we are standing here right now. So this is the major facility for atmospheric science. And this facility is capable of measuring the 3D wind field up to the lower stratosphere. So that's why name comes stratosphere tropospheric radar. Now, this facility is also unique in the sense because this is located at the top of the building and operating at the frequency of 206.5 megahertz. And this is not tried worldwide anywhere.
The scientist of Ares has designed sophisticated instruments like the charge couple device or the CCD imager and the faint object spectrographic camera or FOSC, which brings us the sharp images. This is the first FOSC designed and assembled in India at Ares.
4K CCD imager is an imaging device which will be mounted at the 3.6 meter focal plane, and it's an in-house developed instrument which will do broadband imaging.
There are two types of observing facilities at Ares: solar and stellar observations. For solar observations, Ares operates a 15 centimeter optical telescope at Manora Peak. For stellar observation in the optical and near-infrared or NIR bands, Ares operates a 1.0 meter Sampurnanand telescope at Manora Peak. In 2010, the scientists at Ares decided to move to a distance of 60 kilometers further away from the Manora Peak to a place called Devasthal. Here, Ares installed and operationalized its first 1.3 meter modern optical telescope. Hence, in the middle of 2015, India's largest and most advanced 3.6 meter Devasthal optical telescope, or the DOT telescope, was successfully installed after decade-long efforts at Devasthal. Commissioned as an international collaboration between Department of Science and Technology, India and Belgium Science Department, BEL-SPO.
When telescope is moving from one object to another, it can align primary and secondary mirror online, and it can produce sharp images.
In addition, a 4-meter aperture international liquid mirror telescope in scientific collaboration with Belgium and Canada is expected to become operational soon at Devasthal. Since its inception, Ares have been constantly contributing in the area of astronomical research, particularly those involving time-critical phenomena. For example, the first successful attempt in the country to observe optical afterglow of gamma-ray burst was carried out at Ares. On the academic front, Ares offers PhD and postdoctoral fellowships programs to students as part of its mandate to develop skilled human resources. Various workshops and events are being organized by the Institute as a part of public outreach program from time to time. The observatory is open to public for the night sky viewing. Visitors attend the slideshows and view the picture gallery describing the celestial bodies.
Ares being a public funded research institutions, we see this activity as a very major activity and as one of the social scientific responsibilities of the institute.
In the future, Ares aims to establish a strong synergy between all its facilities and other national and international ground-based facilities and space programs to probe and understand the celestial phenomena in astrophysical terms. Ares is continuously maintaining and upgrading its existing facilities and collaborating with international institutions to carry out observations in the frontier areas of astronomy.
The Department of Science and Technology is completing 50 glorious years in the service of the nation through science and technology. This journey of relevance and excellence has not been a solitary one. All our autonomous organizations have played a critical role in driving forth with quality and focus and speed in their respective areas. They have excelled in their pursuits. I wish all the autonomous organizations and their scientists a very successful future. The future is coming at us at faster and faster speeds. I'm sure you'll be fully prepared to meet the challenges and create new opportunities and work for an Atmanirbhar Bharat that can be proud of its S&T depth and spread.
Aryabhatta Research Institute of Observational Sciences has established itself as a premier research organization in the field of astronomical sciences, which is on a quest to solve mysteries of the outer space.
Okay, so with that video, I am guessing that you got an overview of what we do at Aries. Okay, there are big telescopes that scientists over here use to study stars, planets around other stars, which are called as exoplanets. They study galaxies, black holes, exploding stars, things like that. We also have atmospheric science division, where there are people who study the pollution, the weather phenomena, how in these kind of conditions, when it is raining heavily or there are thunderstorms, so how that affects the atmospheric parameters, things like that. That's what is studied from. Yes. Yeah. Yeah. I mean, the institute is made up of scientists and engineers, and there are some other support staff as well to help us run the facilities, help us run the activities of the institutes and things like that. But there are scientists and engineers. Yes. So the bigger telescope is there in our other campus, which is called Devasthal. It's about 60 kilometers from here. In this campus, we have a 1 meter telescope, the old white color telescope that you saw. In dry weather conditions, we would have gone and seen that telescope. But because it has rained, the ground will be, all wet. And if you go there, the telescope floor also will become all wet, and then, the humidity and all will not be very good for the telescope. So that's why we'll avoid that. Okay. Yeah, somebody here was raising a hand. Yes.
Yeah, so the people I can see in the photos, did they make Aries?
No. So there are some very eminent people in astronomy, in physics. So like, for example, there you have Dr. C.V. Raman. So C.V. Raman was the person who discovered the Raman effect. And he, I mean, after his name, to honor him, basically, the National Science Day is celebrated on 28th February. Here, this is Professor S. Chandrasekhar. He was nephew of Professor C.V. Raman. And so he basically predicted that, stars which are like huge in mass, stars which are much more massive than our sun, when they will end at the end of their life, they will explode and it will form a black hole. He did not call it black hole. That name was given by someone else. But basically, he was the first person to, mathematically show that, with proper proof that something like this will happen. And here you have Professor M.K. Venu Bapu. So he was a young astronomer who came here at Aries when it was called as UP State Observatory in the very initial days of Aries. The Aries had started as UP State Observatory. You might have seen in the video in Varanasi in 1954. And just after a few years, he joined, and he was here for a few years. And some of the initial, so he was the chief astronomer at that time. So he was the major person in the observatory. And so he initially guided the UP State Observatory, with how the astronomy should be done and things like that. And he also thought that, India should have a 4-meter size telescope of its own. And through his initial idea, basically later on, a telescope like 3.6 meter Devasthal optical telescope came into existence. Yes. 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 I mean, the video that you saw was about 4.5 year old. So that's why, I mean, the liquid mirror telescope was just being made at that time. But for the last 2.5 years, it's already operational. And we have already got the data from that. Already some research paper have come out of that. Scientists are using that. Yes. Anything else? All right. So now we'll talk about something like very basic and very simple. Like, so this is called as reasons behind seasons. So what all seasons do we have? Okay, so you are segregating a lot out there. So here, I mean, in India, our monsoon, the major monsoon that we get is during the summer season. So in that sense, the major season is summer and winter. There are countries where they get major monsoon during the winter time as well. So the monsoon depends on a lot of factors which are part of meteorology and weather monitoring and things like that. So we'll not be talking about monsoon because that will be a totally different and very complex thing. We will be looking after the astronomical reasons behind seasons. Okay. So with that, I mean, we can broadly divide the seasons into summer, winter, and spring and autumn. Okay. So summer would be which months? May, June, July, August also you can say. Of course, it rains, so it doesn't feel that hot at that time. But yes, August also would be summer. Then what would be autumn? September and October. Okay, your pre-winter, what you said, could be part of that. And then what would be the winter season? Yeah, November, December, January, and maybe February as well. Okay, although now even in February we start feeling a bit hot because of the climate change and things like that. So keeping that aside, and finally, what would be the spring? March and April mostly. Okay, so we will see what are the reasons why do we have these different seasons. Okay, so again, it's the same thing, like how you would expect the seasons to be at a given place if you see it throughout the year. And obviously, you would require appropriate clothing for different seasons. As I said, that we will not be focusing on the rainy season because our monsoon is basically part of mainly the summer. And if you see, closer to the hills and certain places in India, you also get some rain in the winter. Like for example, here you see that today it's raining. Okay, so yeah, so these are the two major differences that one can quickly notice. That in summer you feel all sweaty, you get tired if you go outside. It feels very hot. During the winters, particularly in North India, the winters are quite cold. You require multiple layers of clothing. So why is this difference? What is causing this difference? Is the sun becoming hotter and colder in different seasons? It could be possible, no? No? Yes? Yes? Anybody? Yes, there at the back? Yes? Okay. Okay. Okay, fine. Somebody here at the back? Anyone? Yes? Same thing? Okay. Yes?
So for example, India is on one side, and when India is facing the sun, at that time it's summer. But then when it faces the opposite direction of the sun, it's winter.
Okay. But that's what happens during the night time, right? Okay, there.
So because Earth is tilted on an axis, so when it rotates, it
Okay.
on the orbit, it's on different like shape. It's on different positions. So sometimes it's like straight on its axis, sometimes it's usually tilted. So whenever it's tilted, whichever side the sun's on, that time is summer.
Which class are you in?
6th.
Okay, fine. So, yes, here, orange.
Sir, it can also depend that the sun is mostly giving its heat to the northern hemisphere, which makes the northern hemisphere as summertime
Hmm.
and the southern hemisphere as winter time. And as the sun is pointing towards the giving more heat towards the southern hemisphere, so the southern hemisphere is hotter than the northern hemisphere.
Okay. So now we will not, take more answers because Javed will have to keep on running here and there. So let us, see in this next few slides what is the situation. Okay, what is happening? Like you all gave different answers. Some people thought that probably Earth is getting closer and farther away from the sun. Someone said that it's winter. Someone said that northern hemisphere gets more light and heat. So let us see what is basically happening. So does anyone think that this is happening? The sun is becoming hotter and it's becoming colder? No? Okay, fine. So, I mean, it could be an answer, but it's not the right answer. So yes, you guys are correct that this is not the situation. Next one. What is causing the difference? Is it due to the distance between Earth and sun changing? Okay, how many of you agree? Okay, most of you agree. Okay, and all right, fine. So let us see. I mean, there were very few people who did not agree with this statement. So let us see what is happening. So Earth's orbit around the sun, okay, it's nearly circular. Okay, we study in the classes that it's elliptical, but elliptical it is, but it's nearly circular. It's not an exact circle, but it's quite close to the circle. Okay. Yes. Okay, is that so? The thinking you are okay. I mean, it shows that when you give different answer, it shows that you are trying to think something logically. So that's good because scientists do that only. But when you think something, then you try to test that, okay, by doing some observation. Yes. Okay, let us see what is true among all this. So Earth's orbit is nearly circular as it moves around the sun, okay, or as it revolves around the sun. So it's closest to the sun in January. Okay, on 4th January, actually, the Earth is closest to the sun. And sometime in July, I'm forgetting the exact date, but sometime in July, it's the farthest from the sun. So if that is the case, so if Earth is closer to the sun, it should get more heat, right? So if we are getting more heat in January, why do we have winter in January? Yes?
Sir, because the Earth keeps on rotating.
Mhm.
So as we see in the picture, in January, the other side of like the other side of the Earth is closer to the sun, but the opposite side of it is a bit far. Like it's not
So
the sun rays is not exactly able
Okay,
to reach that position.
so do you mean to say, like, for example, this side is closer and this side is farther away?
Yes, sir.
But if it will be daytime, okay, after 12 hours, this side where it is night, it will come on this side. That will be in day, right? So that will be closer. So in just 12 hours, is the season changing? No, right? And the entire month of January, I mean, you're from Delhi, so you see that at your home also, right? That entire month of January is quite cold. So what's happening? I mean, and if you see when Earth is further away in July, so I mean that part is summer for us, But again, if you apply the same logic that you just said, then this part is further away. And when it will be night, then that should also get cold. But in July, whether it doesn't matter, whether it's, I mean, daytime, nighttime, it's hot. So what's happening? Yes. Closer on the sides. On this side, it's closer. Could you speak a little louder? No, fine. No, tell me whatever you are thinking. See, you don't have to feel shy. No? Okay. All right. Yeah, but that is the difference between day and night. That's not the reason of season. Okay. So let us see. Okay, let us examine this. So if this is the situation, and if you see the distance, so it's about 147 million kilometers when the Earth is closest to the sun, and at the farthest, it's about 152 million kilometers. And the number could be off by a little, but it's about that. Okay, the number after decimal might be a little different, but more or less that is the situation. Yes. Just pass on the.
Sir, I heard on Google it said like humans can see 30,000 or 30 miles, something like that. But then how do we see the sun?
Let us talk about that after the talk. Okay?
And
When we just interact.
do the
Yes, sir.
seasons change because of gods or something?
No. So we will see that the nature itself has answer. Okay, the
Okay.
way Earth is moving, and then we will see the answers in the next slides. Okay, let us go ahead. So if you see the average distance of Sun and Earth, it's about 150 million kilometers. So the change from 150 million kilometers on the shortest side and on the longest side is barely about 2%. Okay, so that's not the major reason of changes in the temperature. And when we say that Earth is closer or farther away, so does the entire world experience the same kind of season? Okay. Yeah, but again, that is the difference of day and night. That's not the difference of season. Difference of season. Yeah.
It depends on the hemisphere. Like, if it's summer in the northern hemisphere, it is winters in the southern hemisphere.
Right. So northern hemisphere experiences summer in June, July, and winter in December, January. Okay. Similarly, the southern hemisphere, it will be ulta. So in southern hemisphere, it's winter in June, July, and it's summer in December, January. So as someone rightly just guessed, that the seasons in different hemispheres are different. So like for us, like you can see that this our photo of our office where we are sitting just outside. This was the situation in January 2022. I mean, this year it was not that cold, but sometimes we do get snowfall over here. Okay, once every few years or so, it does happen. Our other campus, Devastal, which I was just mentioning, that is at an even higher height. So there, every year, once or twice, we get snowfall. So in January, here in Uttarakhand and India, we have winter. And in January, in Australia, in the southern hemisphere, we have summer. And that's why you see so many people out on the beach, enjoying swimming and water sports. Yes. Okay.
So in that, like, it was so hot that people were like turn on the AC on the beach.
Oh, so what month was
Yeah.
that? Do you remember?
I went in 2024. I think I came in January only.
January. So yeah, I mean, you don't have to believe me. Your friend is telling that straight away. Yes. Sorry.
Celebrate Christmas in shorts.
Right. they celebrate Christmas in shorts. But if you see in northern hemisphere, particularly in
It's
Europe,
opposite.
yeah, it's opposite. Right? I mean, they get like places in Canada and Norway and Finland, they will get snowfall around that time. Yeah, yes, at the back.
So 1 year ago, my sister's friend went to Australia for her business work, and and my sister friend was working in the southern hemisphere. She so she wear jacket in July, and she wore half sleeves in January.
Right. So yeah, you are hearing two examples. Okay, that the situation is completely opposite to what we experience here in India. Okay, so one major reason for that is that Earth is tilted, and you must have heard that, right? Yes.
So also because of the season change, they also have some what do we call?
That's all right. You can tell me later if you forgot.
Okay, sir.
Okay. Let us go ahead. Okay. We can interact more once we finish this. Yes, obviously. No. So there are multiple things here. One, Africa is not one country. It's a big continent. Yeah. So the countries which are at equator, for them, the changes in the temperature will be very less. Okay. You'll realize that very soon. No, they do. They do. I mean, it's not like, see, ultimately the situation has remained the same, or the seasons have remained more or less the same for many, many years. Okay. So, I mean, yes, exactly. So they have adapted, the crops there might have adapted to, hotter climates like that. Yeah, perhaps, yes. Okay. Yes. Hmm. Oh, very good question. Yes, they are. But the amount of tilt will be different for different planets. Okay. So let us come back to this. So Earth is tilted. Let us take the questions and discussion. Okay. Yes.
Half of it have winter, and half of it will have summer.
The next few slides will answer your question. Okay. So Earth is tilted. Okay. Some of you might have heard this. So is it the correct picture to show? No. Okay. Then what is the correct picture? It's something like this. Okay. So this north and south, which is marked over here. Okay. This basically represents your axis of rotation of the Earth. Okay. Fine. Earth is tilted. Then why should that cause changes in the temperature? Okay. Let us see that. And when we say that it is tilted, then based on what? I mean, we are here on Earth. Do we feel that Earth is tilted being on ground? I mean, of course, now we know that by doing observations of sun and things like that, and by studying how the Earth moves around the sun and this and that. But when we say that it is tilted, what does it mean? So this is the Earth axis, right? This pink color line, correct? And then here, this perpendicular to that, another pink color line is there, which is basically the Earth's equator. Okay, and it's not basically a line; it's actually a circle around the Earth, because here you see Earth as a circle, but it's actually a spherical body, right? It's a round-shaped body. Exactly, it's not a perfect sphere; it's bulged at the equator, but it's a round body. So if you look at the equator, it's basically a circle in the middle of Earth, right? Yes. No, the shape of Earth does not have anything to do with the climate change. Okay? The shape of the Earth is because of how much Earth has mass, okay, how much matter there is, and the way Earth rotates. Okay, if it rotates faster, it will flatten up more. Okay, it will become bigger in the equator. If it rotates slower, it would have become, more rounder and closer to a sphere. All right. So what is it tilted with respect to? So if you see the Earth's orbit around the sun, okay, this dotted line that you see over here, it represents the orbital plane of Earth. Okay, Earth moves around the sun like this. Okay, so that plane is represented by this. Okay, this dotted line that you see, and Earth is tilted with respect to that plane. Okay, so if imagine if this is the plane, Earth is not like this; it is like this. Understood? Okay, fine. Then why do we get seasons because of this tilt? Yes. It rotates from west to east. It also revolves in the same direction, west to east. All right. So fine, Earth is tilted and Earth is revolving around the sun. So does it revolve as shown over here? Okay. You have the sun over here, you have Earth over here. Okay, it's tilted like this. You have Earth on the opposite side, and its tilt is also opposite. So does it spin like this? So, or if you see it from, yeah. So basically, no. That's what you also said, that its tilt does not change. Yes.
I've been wanting to ask a question, and it's that during the winter break, I visited Mumbai, but over there, people were standing there in shorts. They didn't have to wear any winter clothes, and during the summer, it stays warm. So it's not that during the summertime it's winter; it's that throughout the year it's summer. Why is that?
Right. So again, the partial answer to that is similar to what question I think one of you asked about why. Africa, the continent, and many of the countries in Africa which are closer to the equator, you should have more or less the same season. Okay, there. So all these reasons are related. We'll see in the next few slides. So no, the direction of the tilt does not change as the Earth goes around the sun. Okay, so whether you observe the Earth at this place or at this place 6 months later, the tilt direction does not change like this. It remains the same. So if you observe the Earth, it will be like this. Over here, when it comes, the tilt will remain same. Okay? Of course, if you observe from the other side, like we are seen from this side, right? If you were on the other side and then you were looking, we will just see that the tilt is on this direction. Okay. Yeah, both sides it will be same. That direction of tilt is not changing. Okay, understood what I said? So either you say this way or either you say this way. It just depends on from where you are seeing. Okay, but that direction of the tilt or the axis will not move or rotate from its position. Okay, that will not be pointing in different direction. Over 1 year, actually, that's true. Over thousands of years, actually, the Earth's axial tilt also changes its direction minutely, but that happens over thousands of years. So we don't have to worry about that, okay, when we are discussing season. Yes. Right. So, correct. So good observation. Again, the answers are related. We'll see in the next few slides. Okay, so now we know that the Earth is tilted. It's also revolving around the sun, and its axial tilt does not change its direction. It remains the same. Okay. So for example, if you see the month of June, okay, the direction is like this. If you see the month of September, again, the direction is like this. If you see the winter, the direction is like this. And in December, and if you see March, again, the direction is like this. Now you see the names of the seasons which are mentioned. So the seasons are mentioned for Northern Hemisphere in yellow color, and for Southern Hemisphere, they are mentioned in white color. Okay. So do you see that they are opposite? Like for Northern Hemisphere, it's summer, but for Southern Hemisphere, it's winter. Okay. And for Northern Hemisphere, it's winter, and at that time, you have summer in the Southern Hemisphere. Similarly, when it is spring, for us, someone in Southern Hemisphere will experience autumn, and when we have autumn, someone in Southern Hemisphere will have spring. Okay. So, okay, fine. Earth is moving, it's orbiting. Yes. So the dates basically mention 4 important positions in the orbit of Earth as they move around the sun. Okay. So this is called as summer solstice for Northern Hemisphere, or June solstice. It varies between 28th, 21, sometime even early hours of 22nd June, depending upon where you are, because most of the time we have time zones which are quite wide. Like for example, the entire country of India, we have only one single time zone, right? There are different countries which have different time zones. Like if you go to Russia, there are I think 9 time zones or 7. US has 4, right? So it varies. And if you see this March 20 or 21st, or September 22nd or 23rd, that is called as vernal equinox, or March equinox, or autumnal equinox, or September equinox. So in these positions, basically as the Earth is rotating, you will see the sun going higher up in the sky or lower up in the sky at noon time. At its highest position, it will not be this at the same exact space, as you go throughout the year. You see the position of the sun in the sky appear to be changing to us. Again, that is because of this tilt. Now imagine this simple experiment. If we have a torch, okay, and if we turn on the torch, okay, and we are shining the light on a piece of paper. When we have that torch perfectly perpendicular or perfectly at 90 degrees to the paper, the light will make a small circle, right? But if we tilt the torch in one direction and the light of the torch is going obliquely, okay, at some angle, will that remain a circle? No, it will become an elongated oval, right? And the more we tilt, the bigger that oval will become. Correct? The same thing happens with the sun. So if we see the sun when it is very high up in the sky, I mean, for simplicity, it is shown at almost at 90 degree. But when it is very high in the sky, the sunlight will be coming at a very high angle, and they will fall in a small area. When the sun is at very low angle, the same amount of light will get spread over a much larger area. And you see this during the noon time and sunrise and sunset time as well, right? Shadows, exactly, very good. So if we look at the shadows, the length of the shadows changes. That is again the indication of that. So what is happening? Now if we pick up a given time, and if we see the sunlight, how it falls at different locations on Earth, like for example, if we are over here at low latitudes and at equator, yes. Exactly. Right. Exactly. Very good. So here at low latitudes for people like us, and even in India, you go to lower latitudes, places like Kerala, Tamil Nadu, Karnataka, Mumbai, Goa. There, you have read about Tropic of Cancer and Tropic of Capricorn, right? So when you are in that tropical belt, within that tropical belt, the sunlight comes at very, very high angle. Okay, so you can see the gap between these two yellow rays. Okay, it is distributed over this much of area, right? But if you go to high latitude, the same amount of light is getting distributed over a much larger area, right? Correct? Right, precisely. The Earth is a sphere. So as a result, when you see the sunlight, the way it falls, if it falls at places which are close to the equator, the sunlight will be more or less vertical or close to vertical, or maybe at very high angle. But if you go to high latitudes, they will come at very shallow angle. Yes, you are raising hand. Yes. Yes, exactly. And if you look at one given place and you look at different times, so like for example, when you go back, you try to observe this in Delhi. Like when do you see the sun very high in the sky? You will notice that in June it's very, very high in the sky at noon. Okay, but if you see in winter, I mean, I know that there is some fog and all, but when you can see the sun in the winter, you will notice that it's not that high in the sky as in June. It will be much lower in the sky around noon time, right? Yes.
The heat of the sun is more than expected because of climate change.
Yeah, but those effects are, I mean, so that is overall temperature is rising. So summer are also getting hotter and the winter is also getting hotter. Okay. It won't happen like, the summer will remain like that, or the summer will become colder and the winter will become hotter. No, that won't happen. So because of this, again, what happened? Let us see in this position where the sunlight is coming directly to us, okay, or directly overhead. Yes. Yes, it has, but it will affect over a very long period of time. The season change is not because of that. Yes, yes, average temperature, it does affect somewhat. It has a contribution. It's not zero, but it's not the solely 100% reason. Climate change is clearly a reason, because when you see the solar cycle, I mean, yes, the overall high energy radiation also increases during high solar activity times. So you get some contribution from that as well. It heats up the atmosphere more. No, no, no. In just one cycle, it won't affect much. You need to have multiple cycles which are extremely, extremely weak, and over a long period of time, for over many decades, or multiple cycles, then you will see that average temperatures have dropped. In just one cycle, if one cycle is weaker, or if you just look at solar maximum and solar minimum, you won't notice that difference. Yes. Right. So the reason for that is climate change. Okay, all the carbon emissions and all that we are causing, carbon dioxide and all. So these are called as greenhouse gases, and they trap the heat. Okay, when the earth absorbs the light from the sun, okay, that absorbed light is emitted as heat, which is basically the infrared radiation. What is the night vision in CCTV cameras? It's basically that thermal imaging or infrared. Okay? So that is the reason of the overall temperatures rising. So if you see across any season, if you find the average temperature, I'm not talking about only one specific day when the temperature is, extremely high or extremely low. I'm not talking about such instances. If you find the average temperature throughout the year, you will see that, for the past few decades, the temperature is actually, continuously rising, and our human activities are to be blamed for that. So to answer, the axial tilt combined with the revolution of Earth around the sun is the reason why you have different seasons. So like, for example, I was giving you this example. In the northern hemisphere, the sunlight is now falling at high angle. In the southern hemisphere, it is falling at shallow angle or at small angle. Okay. So that's why in the northern hemisphere, it's summer, and here it is winter. Whereas if you come on the opposite side, in December, we are getting sunlight at shallower angle or at smaller angle. So the light is getting distributed over a larger area. So that's why it feels colder to us in December and January, whereas in the southern hemisphere, it feels hotter. Yes. So let us go back to this image. Okay. So you see this. Okay. This much amount of light, when it is coming at high angle, it is distributed over a smaller area, right? The same amount of light when it comes at shallow angles, okay? The light is coming at a very low angle from the sun to the ground. The same amount of light get distributed over a larger area, okay? Like this. So this orange circle versus this yellow oval. Can you see? So because of that, when the sunlight is more direct, it will be hotter because we are getting more concentrated form of sunlight. Whereas the same amount of light, when it gets distributed over a larger area, the same amount of light will not be as concentrated as when it comes, at a very high angle. Like I gave you the example, right? At noon times, the sunlight is coming at a very high angle, whereas in the morning or just before sunset, it is coming at a very low angle. So in the morning and in the evening, it feels a little less hot or less, the temperatures are lesser as compared to your noon time when the temperatures are higher. So in this position, in June, for northern hemisphere, the sunlight is more direct. That's why it's hotter in the northern hemisphere. But at the same time, in the month of June, July, and May and August to an extent, yes, the southern hemisphere is getting the sunlight at a lower angle. So that's why for them, it is winter. And 6 months down the line, here in December, January, for us in the northern hemisphere, the sunlight is coming at a very low angle. So that's why it's colder. So it's winter. And it's summer for southern hemisphere people, like you just heard for, people in Australia, they have summer, they have hotter environment at that time. So axial tilt or the tilt of the earth and the way it moves around the sun. These are the two reasons.
So when it tilts, the sunlight goes to the area where the middle point is. जैसे कि in the northern hemisphere, when जब हमारा summer होता है तो for some countries maybe like New Zealand, वहाँ पे winter होगा.
Right.
Right.
Correct. But when I guess you wanted to ask like middle point, like somewhere in the middle of the two hemispheres.
Equator जहाँ पे होते
closer
हैं.
to equator. Yes. So there, the change in the angle of sunlight, it does not vary much throughout the year. So as a result, places at the equator or close to equator, they don't experience much change in the temperature. They will, okay, but it will be much more minor. So that's why if you go to low latitudes, if you go to Kerala or Tamil Nadu, you will not have such huge variations in the temperature. And someone was also asking about, Mumbai and Goa and all. So there, then your local geography also comes into picture, Like if you are closer to coastal areas, because the ocean and the sea, it has a huge amount of water. Water absorbs a lot of heat before its temperature rises. So because of the proximity of ocean water or sea, the temperature in the coastal areas does not fluctuate that much. That is again a reason. But if you are at the same latitude, you just go, in some central area away from the coast, there the temperature fluctuations which will be much more. Like Nagpur and Mumbai, you can say. Nagpur is almost like in the central part of India. Okay, of course there is some difference in the latitude, but Nagpur also becomes much hotter and much colder as compared to what people in Mumbai experience. Yes. You want to ask? Okay, just a moment, then let us before take some more questions. Yes. Yeah.
When I used to live in Singapore, it used to be hot like all year round.
Right.
But it used to be like slightly colder during like December and those months.
Okay. So Singapore, again, it's very close to equator. So that's why the temperature fluctuations are less. Why it was colder? Again, you will need to see like what is the local geography. Again, it's not very far from coast. Okay, it's a coastal region. So those effects also will be there. Okay, but the difference will be not as strong as places which are away from the equator. Yeah. Yes.
Earth on the So the placement of the Earth on its orbit doesn't contribute to the reason of season behind the season.
Yes, it does. But again, the primary reason is the way the Earth is tilted, and the position of Earth in its orbit comes into picture only because of that. Like imagine if the Earth was not tilted at all, okay, then irrespective of whether the Earth was over here or over here, the seasonal changes then would have been just based on the change in the distance between Earth and Sun. Okay, there is some change in the distance, but that, as I showed you earlier, it's a very tiny change. Okay, just 2% change.
Okay.
The change in the tilt, or I mean, the tilt is there; it's not changing, but the changes in the way the sunlight falls at a given location throughout the year, that changes because of the Earth's axial tilt and the way Earth moves around in this orbit. So axial tilt is the primary reason, and then the Earth is also revolving around the Sun, right? So that contributes to that. The distance will have very, very minute effect because that changes just 2%. Yes.
So as you said that in North Pole and South Pole, it's almost cold every time.
Yes.
So like the countries, for example, New Zealand, who are closer to North Pole and South Pole, will they also get cold season mostly, or they also get summer for some time?
No. So New Zealand is actually not that close to pole. I mean, it is at a higher latitude as compared to India, but it is not that close to the pole. If you see the map of the world, and if you look at the latitude in New Zealand, it is not at that high latitude in southern hemisphere.
But do they get cold in summertime?
Yes, they do.
Like
They do. Just like we experience hot and cold in India, New Zealand also experience that. But again, there are two things that you need to keep in mind. One, it is close to ocean. Okay, so that effect basically reduces the changes that might have happened, and it is still far away from southern pole. So the effect is not going to be that strong what you will encounter closer to South Pole or in Antarctica. Antarctica also has summer, okay, but even in that summer, the temperature will be just like few degrees Celsius. Or if you go inland, even there, summer temperature might be in -1, -5 like that. And in extreme winters, that can go as low as -80 degrees Celsius.
I had one more
Yes.
question. In December, November, when it was like winter and all, so sometimes sunlight came. So if we are not facing the sun, how did the sunlight
No,
come to
sunlight
us?
is coming. I'm not saying that we are not facing the sun. It's just that the sunlight is coming at a lower angle. At night, we don't face the sun, right? So, but that effect is going to change after 12 hours when the sunrise happens. Okay, 12 hours or maybe slightly more than that as you go higher and higher latitude, the night will become longer during the winter. Okay, so you don't have to worry about that. What you need to keep in mind is that as the earth rotates, even in winter we will get sunlight. Okay, but it will be coming at a very low angle. So the same amount of light will get distributed over a larger area. So effect of the heat will not be as much as when the sun is at very high angle.
We get sunlight for only some time.
No, you do get sunlight, but it comes at a lower angle. That's a different thing that, in North India, the fog and pollution is so much, the smog is so much that many times it happens that we won't even see the sun throughout the day. That effect is a different thing. That's a local geographical effect and the effect of pollution. Here, you wanted to ask me something? Someone was raising hand from here. You wanted to ask something? Okay, yes?
Sir, so does the eastern and western hemisphere matter in the seasons?
No.
It doesn't.
Eastern, western won't matter because you see that the earth rotates, right?
Yeah.
Over 24 hours, every part in the eastern hemisphere as well as western hemisphere, they are going to receive light and they are also going to be in darkness. So day and night will happen. That effect will not change. But when you see in the northern and southern hemisphere, and depending upon where you are, that change is much slower. It does not change in 12 hours. It will change over months. And that's why season also is months long. It takes a lot of time. So our atmosphere, responds very slowly to the sunlight. I mean, suddenly if there is a lot of sunlight, it won't become immediately hot. It takes some time. Yeah, you wanted to show me something. Oh, that's great. Any other question? No? All right. So here then we come to the end of this, and many of you asked a lot of interesting questions. So we have some of the stickers of one of our big telescopes, the 3.6 meter telescopes, and those all who ask questions will get these stickers. Okay, can you distribute some? If you still want to get the sticker, you can ask questions, and okay, you also will get, but first the kids. Here, yeah, okay. Sorry, what is the meter in the telescope? Okay, so the meter is basically size of the mirror that there in the telescope. Okay, so the diameter of that is 3.6 meters. So the bigger the telescope is, the more light it collects. Okay, and as a result, the more light you will collect, the brighter images it will produce, and basically the better quality telescope you have. What is the biggest telescope we have? So right now there are 10-meter size telescopes across the world. I'm talking about optical telescope. Okay, optical telescopes basically mean telescopes which receive the same type of light that our eyes see. Okay, there are other type of telescopes like radio telescopes, gamma ray telescope, X-ray telescope. Let's forget about those. For telescopes which have mirrors which collect the same type of light that we see from our eyes. So 3.6 meter is the biggest in Asia. Okay, that you also saw in the video. Across the world, there are 5 telescopes which are nearly 10-meter in size. Some are slightly bigger, some are slightly smaller, approximately 10 meter. But scientists are even not satisfied with that. They are building even bigger telescopes. So there are 3 big projects. So the biggest of them is called as ELT, or extremely large telescope. Many countries in Europe are building that collectively because it's very, very expensive. So some 13 countries are building that together. And there, the diameter of the mirror is going to be 39.3 meter, more than 100 feet. Yes. Yeah. So let me just complete this. So, I mean, 39-meter is going to be the biggest in the world. The construction of that has already started. There is also another telescope which is 30-meter in size. Okay, so you don't have to, raise your hand. Let me just complete this and then you raise your hand again. Okay, otherwise you'll just get tired. So 30-meter telescope project, India is also a partner in that. So when that telescope becomes functional, I mean, the construction has not started yet. Most likely it should come up in Hawaii in the middle of Pacific Ocean. It will be placed in Hawaii. So it will be under US. US is the main partner in that project. In that, US is there, Canada is there, India is there, Japan is there. No, Belgium is not there in that project. So they are in the 39-meter project. So when that telescope becomes functional, Indian scientists will get 10% time because India is contributing 10% money and then efforts to build that telescope. One by one. Those are the dates. Those are the dates of June. No, where is 20? No, that's not year. That's just the date. Okay. So it's 20th June or 21st June. As I said, that it keeps changing. There could be variation of few hours, and depending upon in which time zone you are, the date could be 20th June or 21st June or even early hours of 22nd June. Okay, for June solstice. Similarly, for December solstice, it could be 21st or 22nd December. And for March equinox, it could be 20th March or 21st March. And for September equinox, it could be 22nd or 23rd September. That indicates that, like where the Earth is going to be for that equinox or solstice position on which date. One by one. Yes. As I said, that based on where exactly the Earth is, the timing varies by few hours. Okay, and then the way our time zones are decided, okay, or they have been decided by us humans, you may experience a change of something like just over a day. So you can have either it on the late hours of 20th June or anytime maybe on 21st June or maybe even early hours of 22nd June. And similarly for other dates as well. Yes. That would be the biggest. I mean, basically, a bigger telescope will be able to see farther because see, how far a telescope can see will depend on a lot of factors. Don't raise your hand. Let me complete and then you raise your hand again. Okay. So when you are observing anything, okay, any faraway celestial object, whether it's a galaxy or a star or whatever, how bright it will appear will depend on how big your telescope is, obviously, because you collect more light, in which place your telescope is located. Like if you put up a telescope in Delhi, can you see many stars? No, right? There is a lot of light pollution. Yes, there is a lot of light pollution. There is also a lot of atmospheric pollution. If you go to plain areas away from the city, yes, the light pollution might be less over there. But then our atmosphere also reduces some of the light. So actually, if you have a small telescope, but if it is located in space, even with that, you'll be able to see, much more. So there is a space-based telescope called James Webb Space Telescope that actually has seen the farthest. Okay? But as I said, that it depends on multiple factors, how bright your objects are. Like if you take the example of say an ant, which might be just 20 meters away from you, will you be able to see the ant? No. I mean, if you really see very carefully and it's a absolutely smooth white color background and there is a black ant, probably you'll be able to see. But otherwise, no. But if it is a truck parked, say 500 meters away, you can see the truck, right? If there is a mountain, say 5 kilometers away, you can see the mountain. So ultimately, it also depends on how big the object is, how bright the object is. Okay, if it is a very, very bright thing, you'll get a lot of light from that. You take the example of say Pluto, it's in our own solar system. You can't see that even with big telescope. You'll just see it as few pixels in your images. But if you see different galaxies, they appear much brighter because there are lot many stars. So it is giving out a lot of light. And even with relatively smaller telescope, you can see galaxies. Somebody else. Let us give chance to those who have not seen. Yeah. So there are certain types of galaxies which have huge black holes in the center, which is eating up a lot of material, lot of gas from nearby stars within the galaxy. And those type of galaxies are the brightest thing that we are able to see from far away. Yes, there.
The liquid one. Is it like you use the normal telescope? Is it like this? Is the usage similar to that, or is it a bit different?
It's a bit different. So, so why liquid mirror telescope is needed? Basically, you want to make bigger mirror in a cheaper manner. So making glass mirrors or telescopes with mirrors, it's actually quite expensive because these mirrors are not your normal mirror that you get in your house, right? These are very special type of glass, and then coating is done. These mirrors also will be heavy, so it's difficult. And then you have to, make it in some specialized lab, and from there you have to take it to top of some remote mountain. So it's extremely challenging. So some people thought that why not explore some options where you can make this mirrors in a simpler manner and easier manner. So then there are two ways to go about that. The biggest single mirror that you can make will be somewhere around 8 meter or so, just over 8 meters. Beyond that, one single mirror becomes so heavy and so difficult to make that it's not possible to make larger mirrors. But I said that there are 10-meter size telescopes already, right? So for 10-meter telescopes and even the next 30-meter, 39-meter telescope, how they do it? They make hexagonal shaped segments. Hexagon, you understand, right? So you have a lot of segments which are hexagonal shaped, and you place a lot of such segments next to each other. And collectively, you make a big mirror. But this technique, again, is very expensive. It requires a lot of technology because you need to, align your mirrors very, very precisely. And how precise? Thousands of times thinner than the thickness of our hair. That much precision you require. So it's very, very expensive. So the liquid mirror technology is a simpler and easier manner and a cheaper manner in which you can make a big telescope. So you take a large bowl, a very shallow bowl, and you pour a lot of mercury in that. Okay. So mercury is a metal which is liquid at low temperatures also. Okay.
But why do people say that mercury is kind of dangerous?
It is not kind of dangerous. It is dangerous. So you have to be very, very careful when people handle that mercury. They wear those PPE kits like you might have seen during COVID times. Okay. Yeah, it's there in the older type thermometer, not the digital ones, but the older type thermometer that you may get in your school lab and all. There they will have those thermometers with mercury. So what happens that this is very, very highly poisonous. So this mercury vapor should not be inhaled, and you should not touch mercury with your skin. So to avoid that, you have to prepare, use a proper, protective kit with all the gloves and all. You have to wear, masks with those gas filters so that mercury vapor does not go inside in your lungs. So all these precautions you have to take care. So what they do, this entire container is basically rotated. There is a motor below that container, and you might have seen in the video that mercury thing was rotating. So because of the rotation, basically this entire mercury spreads out. Like if you take some water in a bucket and just rotate it with your hand, what happens? At the edges, it rises. In the center, it goes down, right? So that's how that concave surface is made. And for telescopes, you basically require a concave mirror. So that's how you make that telescope. Yes, but there is a big limitation, though it is very cheaper and simpler to make. But since it's liquid, you can't move that telescope in any direction because mercury will just spill over, right? So that telescope basically just observes directly over the head. Yes, yeah, you can't. So as the Earth rotates, so it sees a very small part of the sky. And as the Earth rotates, like imagine if this is the mirror and the fingertip is what it sees. Then over the night, as the Earth rotates, it will keep on shifting, right? So it will see a narrow strip of the sky, and it observes that narrow strip and tries to image that different parts of that strip. And then for multiple nights, you will take a lot of data and then you try to compare, try to see if there are any differences. So the liquid mirror telescope works like that. Okay, somebody who has not asked the question. Yes, yes, yes. You will just get tired. Let me just complete an answer. Okay, then you raise your hand, ask a question. When someone asks a question, again you put your hand back down.
Sir, I read in a book that Saturn's one day lasts lesser than one Earth day because it revolves and rotates faster. So, how long
It
does
rotates faster. Yes, revolution is its motion or the planet's motion around the sun. Okay, so that will be faster for a planet which is closest to the sun, right? Because it has to go in a smaller circle. Whereas a planet which is farther away, like Jupiter, Saturn, they will take much longer time because they have to go in a much bigger circle. Like imagine just, taking a small circle in your class and going around in a circle around your school building. Which circle will be bigger? Around your school building, right? So that is obviously going to take longer. So that movement around the sun, that is the year. So that is bigger. For the farther away you go from the sun, the longer it will become. The rotation basically determines the length of the day, and that is faster in the case of Saturn and Jupiter. So it is in just some hours. Like for example, for Jupiter, it's just under 10 hours. For Saturn, I don't remember the exact number. It is slightly bigger than, slightly longer than Jupiter's day, but I'm guessing it might be something like 15, 16 hours, something like that, or maybe 12 hours.
So, sir, in that case, how long would a season on Saturn last?
Season again will depend on the tilt. And in the case of the tilt of Saturn, the way its rings change from Earth, it is over 20 years. So in the case of Sun, like you basically see the entire duration, how much time it takes to go around the Sun, because the tilt does not become like this. If the tilt is like this, it will go around the Sun like this. So after one complete rotation or revolution around the Sun only, you will have complete changes and back to the same season. It's somebody who has not asked the question at the back in the pink. Yes.
So I read on Google that after you go in black hole, you get out of white hole. Is that true?
No. So we don't know what will happen to what is exactly inside a black hole. But what we don't know is that it won't be possible for us to go inside a black hole, because around that, no, event horizon is just a boundary of the black hole. But close to that, the temperature is so high and the change in the gravity is so high that if we go close to a black hole or a place where the gravity is very, very strong, we'll just basically stretch. We will just get stretched like a noodle.
Sir, I had one more question.
Yes.
Sir, so in the that picture, so in June, the sun is like the sun rays are directly going to like near the equator, right? That's why it causes
So closer to the equator, more or less it is always the case. Okay, of course, if you compare even in the northern hemisphere, places which are close to equator, they will have sunlight at a very high angle. Places which are at very low, very high latitude away from the equatorial areas and closer to the poles, they will get the sunlight at a lower angle.
Sir, so in March, so the southern hemisphere is much more closer to the sun.
No. So in March and September, both the hemispheres get same amount of light. Okay. Again, the change in the season is not because of being closer or further away. It is just based on how high the angle is for the sunlight or how low the angle is for sunlight. And that is because of the tilt. The girl in the cap. Yes, yes.
In a summer solstice, basically, is it when those days represent like when it's warmest in summer or winter?
In principle, it should be because the sun is at its highest point. But in reality, usually the days after that are hotter. If you are at a place where this monsoon is not there, okay. Here in India, I mean, it does become quite hot in June, and it would have become probably even hotter in July. But fortunately, monsoon clouds protect us to somewhat because of the rain, temperature drops. Because of the cloud, we don't get all the direct light and all. The reason for that is this: the way our atmosphere absorbs. Over the course of just one night, it does not emit all the heat. It takes some time. So like when during the day it gets heated, during the night it cools down a little bit. The next day again it will get heat. So again it will rise slowly. Again, the next day it will receive some heat, it will rise slowly. So typically the maximum temperatures are achieved sometime after that. Okay. But your local effects, again, as I said, that whether it's proximity of an ocean or sea, presence of clouds, that can totally change. Like if you see in India, mostly our maximum temperatures are typically in June, not in July, because of the monsoon. But if you go to places further north in Europe and all, where they don't have such a strong monsoon, where they might get rain throughout the year in small patches, there the temperatures are typically highest in July and August. And the same thing you also observe in a given day. The sun is the highest at around noon, right? But that's not the hottest time. The highest temperature is somewhere around 2:30 in the afternoon. So the reason is that. But somebody who has not asked a question. Yes. Bigger size telescope. So, as I said, that using telescopes, you basically just collect light. Okay. Imagine like if you have a glass and you have a bucket and it is raining. Where do you collect more water? Bucket, right? So bucket has a much wider opening, so more water is falling in that. And that's why ultimately your collection also will be more. Instead of a small glass, you imagine a telescope with a small mirror or a lens. And instead of bucket, you imagine a big telescope which will have a bigger mirror or bigger lens. And instead of raindrops, you imagine light. What will happen? The smaller telescope will collect less light. The bigger telescope, which has bigger mirror, will collect more light. So when both of these telescopes, you will point to any celestial object, whether it's a star or a planet or a galaxy, in the smaller telescope, you will see a fainter image. In the bigger telescope, you will see a brighter image. Okay. So what it means that there will be many objects which may not be visible in the smaller telescope because they are just too faint and they are beyond the capability of that telescope. In the bigger telescope, they might be visible. They are not visible, you forget that telescope, you take an even bigger telescope. You use that. Usme nahi dikh raha, you forget that, you take an even bigger telescope. That's why astronomers are always interested in making bigger and bigger and bigger telescopes, so that you collect more and more light and you are able to see fainter and fainter objects. So an object will be faint, either it's too far or it may be closer, but it's simply just too faint. Yeah, so basically we want to see the targets which we haven't seen. Wait. Here, yes. It again depends on the purpose. Like a liquid mirror telescope will be much cheaper, but using a liquid mirror telescope, you can't move that telescope and you cannot track the object in the night sky as the Earth rotates. So you see the sun going from east to west, right? If you see the stars at night, they also go from east to west because the Earth is rotating west to east. So if you keep your telescope fixed at a point, what will happen? Whatever star or a galaxy is there in front, immediately it will go out of that and it won't be visible in your telescope. So you have to move your telescope with that object so that you see the same thing for minutes and hours depending upon your requirement of observation. Okay. So in that sense, yes, a telescope which can track the object, that is a better telescope because you will be able to use that telescope to do a much more detailed study. That is possible with 3.6 meter telescope and the 1 meter telescope. It's not possible with the liquid mirror telescope, though it is much cheaper to make. So but for liquid mirror telescope, you will have other applications. Like for example, people are imagining, and they are proposing ideas, then sometime in future when we have colonized the moon for scientific purposes, maybe we can have much bigger liquid mirror telescope in the craters of moon. We may have a telescope of the size of 100 meters. Okay. So, I mean, that is just an idea. Let us see how far we go. No, somebody who has, yeah. Colorful, I mean, it could be for multiple reasons. Typically, colorful जो factor होता है वो उसके वजह से होता है कि like आपके atmosphere में कितना dust है, किस size का dust है. Depending upon the size of the dust, different type of light gets scattered more or less. Like for example, during the daytime, we see the sky as blue, right? That is because the blue light in the Vibgyor spectrum gets scattered the most. So it basically gets distributed all across the sky, and to us, the sky appears blue. The same thing during sunrise and sunset, because the light is coming at a very, very shallow angle. So most of the blue thing gets scattered in different direction, and only the red and orange part is more or less coming straight. So that's why to us, the sun and the nearby region looks orangish or reddish kind of thing. If you go on Mars, you see the sky, the sunrise as blue, because there the red color gets scattered more. So from a given location, how it will look, ultimately it will depend on what's there in the atmosphere, okay, size of that dust and all that. Somebody who has not asked a question. Yes. Okay, let us go with the first one first.
In the Arctic regions, you said that the light scatters. So, like,
no, light comes at a very low angle. Sunlight comes at a very low angle. Yes, of course, because of that it will scatter also more. But yes, go ahead.
Yeah, so like in area nearer to the poles, so we are like in Australia or New Zealand. So there also is gonna be a change of temperature very low.
Yes, to an extent, but actually, if you see the map of the world, Australia and New Zealand are not that close to the pole. They are still 1,000 or kilometer, or probably even more than that, away from the pole. Okay, they are still at something like, I'm guessing, maybe 40 degree or 50 degree, 35 degree latitude, more or less. So it's still not that high latitude. It's similar to Europe, okay, or the southern part of Europe in that sense. Antarctica and then Arctic, or northern part of Finland, Norway, Sweden, they are at high latitude. So there the sunlight that they get is at a very low angle, and that's why the temperature variation between summer and winter is much more extreme over there. The closer you are to the equator, the temperature variation between summer season and winter season will not be as extreme. Somebody who has not asked a question. Yes. Yeah. First you. Yeah. Then we'll go at the back.
Like you were saying that when the stars explode, they make a black hole.
Yes.
But what's the scientific reason behind this?
Oh, if we have to understand that, probably you'll have to sit for the whole day. Okay, so I will tell you in very short manner, and I mean, because see, these things, they took hundreds of scientists, a lot of time, a lot of research was done, and after that it was known. So basically the idea is the energy that we get from stars. Why stars shine? Because in their center, sun is also a star. So in the center of sun and in the center of other stars, there is a process going on which is called as thermonuclear fusion. It's basically hydrogen forming helium. Okay, protons fuse. When you go to higher classes, you learn about protons and what is hydrogen and all that. So they fuse together to form helium. It generates some energy. Later on, it will fuse helium together to form carbon. Again, some energy will be released. Like this process goes on till iron. Iron is the most stable element. So that's why up to that stage, energy will be released. But you cannot fuse iron together to release energy, because this fusion reaction is what releases the energy. So when that energy is released, which is formed in the central part of the star, it goes in all the directions and it generates a pressure in all the directions. Okay? And our gravity, anything which has any mass will have gravity. Even a dust particle has gravity. Of course, it will be much weaker because it has a very low mass. So stars also have gravity because they are huge. There are a lot of material. So gravity tries to, push everything inside. It tries to compress everything. It pushes towards the center. Like wherever you are on Earth, you get pulled towards the center of the Earth, right? So gravity is trying to pull everything towards the center, and this pressure which is generated because of the fusion reaction, it tries to push against this gravity. So there is a balance between the two. Now this goes on till iron, but fusion after iron is not possible because that is the most stable element.
So it takes decades to form.
Not only decades, it takes millions and billions of years. Like if you take the age of sun, it's about 10 billion years. Okay. 1 followed by 10 zeros, you'll have to write. So that is the age of the sun. For bigger stars, it will be shorter than that, but the process is basically the same. And the very massive stars, the sun won't form a black hole, but stars which are much, much, much heavier than the sun, like 10 times, 20 times, 50 times heavier than the sun, they will form black hole. There in the green, yeah, neon green, yes.
So, sir, what's in the middle of the galaxy?
So in the middle of large galaxies, there is something called as a supermassive black hole. Basically, a black hole which is extremely, extremely huge. It can have, like when stars explode and they form a black hole, that will have a mass something like say 3 times or 5 times or 10 times or 50 times the mass of the sun. Okay, they are so massive that we don't use kilograms and all that. We just take mass of the sun as a unit. So for normal black holes or stellar mass black holes, what is called, basically which are formed after a massive star dies, its mass would be something like 10, 20, 30, 50 or 100 times the mass of the sun. But stars, the black holes which are in the center of galaxies, they are extremely huge. They will have mass which is millions to billions of times heavier. So that is there in the center of galaxies. And in some of the galaxies, these black holes also absorb a lot of material from nearby stars and gases in the central part of the galaxy. And these are called as active galactic nuclei or AGN. So they are basically very hungry. They are eating up a lot of matter. Behind you? Yeah, okay. You go ahead and then.
Okay. Do black holes have a life cycle?
Do black holes have life cycle? I don't know the answer to that. Yes, they do. Stars do. So stars are formed. Stars, spend their entire life shining. They evolve. At the end of their life, they will explode. They might form different type of objects, including a black hole, depending upon how heavy they are. So, but whether the black holes have life, different black holes do come closer together. They merge to form a bigger black hole. That does happen. But whether the black holes die or not, that we don't know. We don't have an answer to that. Yeah, it is the end stage of very massive stars in that sense. Wait. Somebody who has not asked the question.
Sir, is there an end of a black hole?
Is there a
End of a black hole?
edge of a black hole?
End
End of a black hole. Again, as I said, I don't know. There are some scientists who think that they have suggested the ways a black hole might, end its life, but we don't know. We haven't observed anything like that. Behind you? Sit down.
Sir, what happens when two stars collide?
Two stars colliding, most likely they will undergo supernova depending upon again how heavy they are, and they might form a black hole or a neutron star. So, but do stars collide? It's very unlikely. It's very unlikely that two stars come so close that they collide. It does happen, but typically it happens closer to the end of their life, or in fact, usually after the stars have ended their life. And so typically it is observed that two black holes come together and merge, or a black hole. And there is another type of object which forms at the end of some stars, which are called as neutron stars. So they come and merge. So that also happens, or
and
two neutron
sir,
stars come together and merge.
do you think that white holes are just a myth or they are actually true?
Yes. Okay. So there is not enough time, as I'm told that you also have to go. So wait. So the question was that what was the question? What was the
Sir, the question was
okay,
that
the white hole. So we don't know. I mean, mathematically, it is given as a concept, but we haven't observed anything like that yet. Yes.
Sir, so Uranus, it like orbits like differently. So is it also tilted?
Yes. In fact, the case of Uranus is much more interesting because it is tilted by 98 degrees. Unlike Earth, which is just 20, yeah, so it's almost like sideways. So seasons on Uranus are extremely extreme. Like for nearly half of its orbit, it will have one kind of season, and for half of its orbit, it will have a different kind of season. So, and they are much more extreme. Somebody who has not asked a question. Okay, you go ahead. When is the longest day on Earth? Again, it will depend on which hemisphere you are in. If you are in northern hemisphere, then it will be 20th or 21st or 22nd June. If you are in the southern hemisphere, it will be 21st or 22nd December. And what would be the length of the day? Again, will depend on how close or how far you are from the equator. Yes. One more here. No. In summers, days are longer. It's the other way around. In winters, the days are shorter. Somebody who has not asked the question. Somebody who has not asked the question.
Excuse me, sir. You were
Nobody?
Have
you got a speaker? Okay, let him ask this question first, and then your will be the last question.
Sir, I read somewhere that like a day in Venus is is like longer than a year in Venus. So how is
Absolutely
that
right.
possible?
Right. It's possible because Venus rotates extremely slowly. So if you see the amount of time it takes Venus to go around the sun, it's about 225 days. Whereas on its own axis, it rotates much slower and it takes about 243 days. So its rotation is actually much slower, and that's why the day on Venus will be much longer. But Venus' case is even more strange because unlike other planets, it actually rotates in the opposite direction. So that's the sorry? No, so Uranus is tilted at 90 degrees. So it moves like a sideways. So if you imagine a spinning top, okay, all other planets go like that, but Uranus moves like a wheel or a tire in its orbit. So it's at 90 degrees. Venus, we think that it's almost like completely opposite. Okay, it has, instead of being this way. So that's why it also rotates in the opposite direction. Okay, last question now.
So you were talking about the James Webb Telescope, right? How many meters is the diameter of it?
So for James Webb, the diameter is about 6.4 meters, 6.4 or 6.44. I don't remember the exact number. I think it's 6.4. But there the requirement is that one, it has to fit inside a rocket. So you can't have a very big telescope. And even if you want to have a big telescope, it is going to be extremely costly. Like James Webb Space Telescope is just 6 meters, but it might be probably costing more than the 30-meter telescope that different countries are building together.
Oh.
So it costed more than $10 billion.
Oh.
Yeah. Yes, $10 billion. Because sending things in space, it's extremely costly. You have to work against the gravity of the Earth, right? And then you also have to ensure that it should survive the journey. So you have to do a lot of tests. And then it's also quite far away from Earth. So you have to ensure that if it reaches its final place where it should start observing, everything should go smoothly and it should start observing. Suppose something goes wrong and the telescope does not work, then the entire money will be wasted, right? So they had to do a lot of tests, they had to develop a lot of technologies, and also it is there in space, it is far away from Earth. So all that has caused its cost to be so high. Okay, so now we will close over here. How many of you did not get a sticker? How many of you did not get a sticker? Only these many? Who did not get sticker? Don't worry, we will give sticker to you as well. Okay. So I think the what probably 15, 20. Yeah, sure. Some of you also can. Yeah, I think. Yeah. We have our science center, but there some renovations are happening, and in fact, our sunspot thing we were going to do there only. But as I said, so some of the things we have already brought outside, the posters and all that, and there we are having some renovation. So that is the no, we won't be able to. Yeah.
Hello students, please settle on your seat only, okay? We will be having one group photo and after that we all will be moving outside, okay? Here only we are going to have a group photo. Hanji. Beta, please settle on your seat. Dear students, please sit silently, okay? Maintain the discipline. And beta, those who are sitting at the back can come forward. Here we have empty chairs, okay? It's just a group photo, don't worry.
Yeah, here only we'll take because outside it's raining, so it will be difficult. We want to go. From science center, we have a 14-inch FPV. I have a public relations. That's in the event telescope for scientific. Just vacate maybe one chair over here. I can sit there. Okay, take it fine.
माइक से बोलिए ज्यादा अच्छा रहेगा.
Yes, beta, those who are at the last, please sit down. And you can move forward even.
Students at